That's funny.
Hmm.
You can see the steam.
Pot smoking.
Something's on fire.
Are you streaming?
Not yet. there's a bit of smoke back here. It's just a ultrasonic diffuser. Nothing's on fire. We're all good. We're making it smell nice in here. Alright, so I'm still waiting for some parts to be 3D printed for Voltron. Unfortunately, I made a mistake this afternoon and have to print the parts now. And I think they'll only be done until, won't be done until about 8 or 8:30. So instead, we'll work on Optimus Prime. There's one bad servo that I found, so we're going to replace that and then get Optimus Prime back in action again. Let's adjust the camera view a bit.
Oh, here's music.
Oh yeah. Adjust this a little.
Something that will block all of our videos forever.
Video blocking music.
Spotify.
Alright, there we go. That's better. Oh no!
What did you do?
One of my cameras is hollowed out. Let's see if I can get it going again. Oh no! Well, I guess it's just going to have to stay there for now. Maybe I'll switch to something else later on. Alright, Ultron. I mean, Optimus. Two of my favorite robots. Where's the speakers?
Well, that's why they're doing it.
Actually, let's test them out. Looks good on there. Share my screen a little bit here. Just get things set up. Oh, I need the Arduino. Let's get that going. Thanks for the tunes.
Oh, music. Oh, what did we say we were going to do today?
Well, yeah, you know you need to be, don't you?
I think I have one.
That one?
Yeah. You gotta take a look on the website and find out what I said I was going to do today. Clickety click.
Alright, let's switch this to
That's me. Boom, boom, boom. What did I say? Where's the title on this? Live hack session. demonstrate Arduino. Oh yeah, Arduino connected to the computer over Bluetooth and USB. Robotus Bioloid with the 360 and play with the indoor position system. Cool. Okay, let's do Arduino. I have an idea for Arduino. I don't think I want to connect it over Bluetooth. Not yet. I'll have an idea first. Let's do something different. Let me grab an Arduino. Box of Arduinos.
I've tried to make them walk before, but it didn't work really well.
Lots of Arduinos. Although Jeremy has a bigger stash of Arduinos than I do. Uno. Let's go with Arduino Uno. It's a good one. Everybody has an Uno. This one here. And a cable. I know what we have to do. Get this guy in there better. That's better. Okay. Yeah. Uno. So I was thinking of doing this. The new version of Easy Builder, it'll actually show you capabilities when you connect with different hardware. So maybe what we'll do is we'll modify the firmware on this Arduino and we'll give it the power of, let's do wheel counting. So we can use the interrupts on it and have it count wheel rotations as an example. And then we'll upload the new firmware to the website. We'll make a plugin too. That'll be fun. Let's do that. So first thing we want to do is on the computer, let's grab the firmware that we have right now. Transition. There we go. Synthium. Let's see. Getting started. Where is it? Getting started. Get hardware here. Microcontrollers. Uno. That's the Uno. Let's go. Here's the source code for the Uno. We'll grab that. Cool. And yes, I use WinRAR. Don't laugh. So we'll throw this into a folder in my documents. I'll just put this in an Arduino folder for the time being. Boom. And jump in there. So I already have the Arduino IDE obviously installed, so when I double click on this, it's going to load up the IDE. Hey Andrew, how you doing, buddy? Aurora Barato, you're back. So what I'm going to do is we're going to modify the firmware that I just downloaded from our website, and we're going to make it so that it'll be a new firmware, and we'll have it set up so it'll count interrupts, and then we'll make a quick plugin that will show you the wheel rotations, the interrupts count on Easy Builder. So first thing we notice here when we go through all these are the different ports that are set up on the Uno. We should find out what the interrupts are on the Uno. I know that if you look at, let's see, if I look at the Mega source code we had, Arduino Uno interrupt reference, here we go. So the Uno has pins 2 and pin 3. That's cool. And attach interrupts. And then there's probably some code that runs. Attach interrupt. Blank. Oh, I see. So what it looks like we're going to do is we're going to set the pin mode into the interrupt pin into input. And we're going to do a pull-up on it. So internally it'll do a pull-up. That way it's not floating. You'll ever notice sometimes when you do something floating, if you put your hand near it, and static electricity causes your software to recognize that it's either shorted or open. That's because you're not using the internal pull-ups. Now the internal pull-ups are small, like really tiny. So you're not going to use them for say I2C or anything, but at least it'll help so that you don't get floating stuff on switches. That's the main reason why they added it, for push buttons and switches. And then attach interrupts. So then they attach to the pin, digital interrupts, pin, and then the function that's going to be executed every time the interrupt occurs is going to be blink, and then the code is unchanged. That's cool. Arduino made it nice and easy to use. So what we're going to do is we're going to do this twice. We're going to do this with pin 2 and pin 3. So because we're going to be using the Uno here, so pin 2 and pin 3. So we'll have this code set up so like pin 2 will be like one wheel, like a left wheel, and pin 3 say would be the right wheel. And we'll count how many wheel rotations. That's what the firmware is going to do. So first thing we want to do is back in our code here. The first digital port we can use is not going to be 2 because 2 is going to be used by the interrupt counter. So we're going to set this instead to, so port 2 will be interrupt, port 3 will be interrupt, so it'll be port 4. And the last pin on the Uno is indeed 14. Yeah, because it starts at 0. And analog pins are able to change. The firmware, we're going to have to change this. So I've already set up a firmware, which is just called 0x0000B. That's already configured. And hey, Heatrocks. So what we're going to do here is we have this, well, these are all the different functions that EasyBuilder, all the different commands EasyBuilder will talk to the EasyB with. And then there's like subcommands. What we're going to do is we're going to modify this command. We'll take this command and we're going to add it to be our own. So what I'm going to do is I'm going to rename this from unknown to command custom. And then what we'll do is we'll drop down into the actual code where this is where the EasyB protocol it's called. This is every time there's a new command comes in, it reads the byte and then it runs through and processes what that command is. So we'll just go to the very end of this list and we're going to add our own command to this list right here. Else if command equals command custom. And let's give it a better name than that. Let's call it command our custom commands. We'll do that. They might throw more than just one in there. And then, so that's going to just be caught at every time EasyBuilder sends that, and our plugin will send that. So next thing we want to do is we want to read another command, which is going to be like a subcommand. So we'll just call it command 2, read byte. And that reads it from the input buffer. And then what we'll do here is we'll say if command 2 equals, in this case we'll go 0x00. and we're going to return the count of both of the interrupts. So what we'll do is it'll be 2 bytes expected. So first let's set up the interrupt code. So let's go into our setup here. Boom, boom, boom. And let's set up our interrupts. So back to our Arduino reference here, we have some example code, which is nice. So we'll grab these two and paste this in here. And we'll set this up for D2. We'll call this like left wheel, for example. Doesn't have to be. And then we'll make this one D3. Right wheel. And then input and digital pin, which will be D2. And this one here will be D3. That's weird. Digital pin to interrupt. Attach interrupt. It's strange. I wonder what that function does. You think you would just be able to pass in the... Oh, here we go. Interrupt. This one's recommended, not recommended on the Duo, 0, or 101. Oh, that's... It's weird language for this. Say not recommended. I think it's supposed to say not recommended, period. Arduino Duo 0 MKR or 101 only. I think it's what it's supposed to say. Unless it's trying to say it's not recommended for these. Who knows? Let's just use this one. That's the one that's suggested anyway. So D2, D3. Then we don't want to call it blink. We'll just call this count left. And we'll call this one count right. And then we're going to create 2 variables for counting. So we'll have an unsigned int. Now I believe a word size of an Arduino is it 16 or 32? I'm sure it's 16, right? 16-bit. So that gives us 65,000 counts. I'm sure that's going to be fine. Let's use that. So we'll put in here wheel left count, and this one will be wheel right count. Okay, and then back to our setup. So we're going to run these. These don't exist right now. We have to create these. So let's create what it's saying here. We have to create no parameters expected. So that's fine. So we'll just go void count left, and then a void count right. There, so now we got these 2 interrupts will execute every time these interrupts flick, right? So if we have a wheel that's spinning and it's got a little counter on it of some sort, then it'll, like whether it's a light or sometimes they're magnets, it'll trigger every time it rotates once. And here's our count. So what we're going to do is take those 2 variables we created. There we go. And add that to it. And do this one too. Pretty simple, really. That's it. So we want to return these values. Boop, boop. Whenever this CMD sends, so first Easy Builder will send this, which is a 0x00, right? And I don't know if that's how we spelt it before. Our custom command, it looks like the paste didn't work very well. There we go. Command, our custom command. And then it's going to send another command, which will be a sub command. And that sub command will be 0x00, which means send me 2 bytes, two integers, which are 16-bit each. So we'll go right 16, left wheel, and then right 16, right wheel. So Easy Builder our plugin will expect these 2. And then we can do another one of these. This time we can say else. And we can make this one 0, 1. This time maybe we can call this one, here, this will just be called I'll put some comments in here so you can read. Get wheel counts. Get both wheel counts.
Hello, Andrew. Welcome.
And then this one will say, rather than get both wheel counts, we'll get both counts and reset. So once it's done getting it,
So for those of you
we'll
just
reset
joining,
these.
just
counts.
reprinting some items for Voltron. Yeah, it's going to take a little bit.
There we
Reprint
go.
some stuff.
And for fun, I guess we can make a fourth or a third parameter here. For fun, because it's a Friday night and we're crazy. We're gonna make another parameter called.
Alright.
Geez, Arduino inserts like a semi or a squirrely bracket every time you put one in, and I always get confused because I'm not expecting it to do that. We'll call this one just reset wheel counts, and we won't even get the values, but just totally reset. Boom. So we'll probably want to do this if your plugin is ever going to like start from scratch or need to recalibrate itself or something. Boom. There we go. Okay, so now we can compile this and see if it works. So I'm pretty sure we did everything we needed to do. All right, we boom, 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 started up port 4, and we changed our firmware ID so Easy Builder will recognize it. And you guys will know more about this soon, next week hopefully. We have a new section of the website which will allow you to create and upload your own firmwares and add your own hardware, but right now it's something I have to do in the back end. So this is a firmware B for back end firmware. Sounds dirtier than it actually is. No, so let's go down. Okay, so this is our setup. So we set up our left wheel on D2, our wheel on D3. Boom, boom, looks good. That's what they said here. Oh yeah, you don't put D's, right? You just put the number, 13? Let's see, compile. It should give me an error if that's the case. She's compiling. Utility delay. What? Why are you unhappy with something that you've never been unhappy with before? You have no reason to complain about this. Maybe it's because of a different error. No. Send software utility delay.
Let's check out the forward.
Huh. Maybe it is because I did this. I don't know. This is like my 5th time using Arduino ever, so I'm not sure if it's like D's or if it's just numbers. But why am I getting an error here? That's not right. Oh, I know why. Because if I look under my tools, yeah, look at that. I'm trying to program for a microbit. That's not going to help us. We want to use an Uno. You are the only Uno. Compile. Alright, she's building. And our command custom is not in this scope. Maybe we did call it something weird up here. Let's go check. What did we call it? Our command, our custom commands. It's supposed to have an S on the end, that's why. Guys, you aren't paying attention? Come on. You're supposed to tell me, fix these things for me. So let's paste this here. There we go. Okay, so if this compiles, which I think it will, tick-tock. There we go. Nice. Okay, so this will count, increase these two values every time there's an interrupt on 2 or 3, pin 2 or 3, and then we can, from our Easy Builder plugin, which doesn't exist yet, we'll be able to query these values. Oh, this is going to be super cool. I've always wanted to have a wheel encoder counter thingamajiggy. That's the technical term. Oh, we're also wrong here. Do you guys notice? I said command 2 equals 0, 0. That gets both wheels. Command 2 equals 0, 1. Get both wheels and count reset. But then I'm also like command 0 equals 0, 1. See? Cut and paste. Here we go. This is reset wheel counts. Boom. So let's just put these in Notepad for the time being so I don't forget once we get into the plugin. So 0x00 is our main custom command, and then 0x00 sub is our get both wheel counts. 0x01 is, and the great thing about Easy Builder, it's what I love about this is like I do all this work, or you know someone like PTP or somebody creates these plugins and creates all this work and then gives it to you guys, and you guys don't actually have to do any of this. So you're probably like glazing over thinking, what is all this code? 0x01? Am I just making this up? Get both wheel counts and reset. And then once this is an Easy Builder, you won't have to know any of these things. Get reset wheel counts. There. So let's save this. And let's program the Arduino. Let's do that. At least that way we have it on there so we can start testing once we get the plugin working here. How can I show you? Boom. There you go. So here's our Arduino. We'll give it some USB juice and plug it in. Cool. Now just to make sure that this is actually working, let's plug a servo into it, and we'll at least make a servo move first. That'll give us an idea. So let me turn on my power supply. No, not a low-on servo, not for this thing. I just happen to have a box of servos we can use here. You're obsessed with the low-on servos. So we'll plug this into, so we can't use 0, 1, 2, or 3 because those are being used by the, so 0 and 1 is being used by the USB, and 2 and 3 is being used by our interrupts for the counter. So let's put this into, I don't know, 6, 5. Put this into 5. And let's give it some voltages. All right. And then back to our software. Let's load up Easy Builder. So today I'm going to be using a beta build of Easy Builder, and it is 2019-02-08. Oh, look at that. It's today's. Cool. So in order to connect to it, it's going to be USB, so we want to select the COM port. But we also need to know the baud rate because UART or serial uses baud rates. And even though it's USB, it's still on the other end is a serial port. So let's go back to our code, scroll to the top. And where's our baud rate? There it is, 57.6. Nice. I think for this device, that's pretty good. I don't know how much the hardware UART can do.
Oh, sorry, Andrew. I don't have too much info on that.
So we'll select 57.6. Booyah. Connect to it. Nice. Okay. So you can see down here we got our capability. So let's add our debug window in here and take a look and see what we got. So this thing returned itself as firmware DJs Uno V1, Arduino Uno, and it supports 10-bit resolution, servos, transmit. All right, we actually haven't programmed the Arduino yet because what it's telling me is not the firmware that we're actually using. So let's disconnect, clear this, and we'll go back to our code here. Now let's actually program the controller because last time we just compiled it. So let's actually program it. Clickety click. Bob a trick. Programming. Problem uploading the board. Probably because I haven't selected the COM port. That is right. There we go. Let's try this now. Compiling, uploading. We're using a lot of memory. 65%. Okay, cool. Now it's programmed. So let's go back into Easy Builder. And now we push the connect button magically. Look at that. Now it says DJ's Uno wheel encoder V1. That is exactly what we're working on today. And it's an ADC with 10-bit resolution. It has digital ports, servo ports. And if you look right down here, it says counts wheel encoder rotation. It's exactly what we just set up. Okay, now there's no plugin yet to do this, so we have to make a plugin that can actually do this. But first, let's see if we can move a servo. So let's add, and no, not a Luan servo. Servos horizontal, and we'll configure this. What did they say we plugged it into again? D5. So we'll select D5 from the list. Booyah. And then move this. And oh no, it disconnected. Why did it disconnect? Is D5 not a good port for servos on a Arduino? Must be. Hums. Interesting. Okay. Well then let's try a different port. Let's put this on D6.
Oh, nice.
And let's try D6. So first we have to reconnect to the Arduino. If it didn't crash. Okay, it didn't. And we'll change this to D6. And let's try moving a servo. Okay, there we go. So D5 must have, I don't know, Arduino's crazy. They're all, there's not a really good standard on it across on Arduinos. So let me show you the servo moving so you can see it. There we go. Cool. So we know that the servo is working with the Arduino. Now we can start counting some data. So let's get back to our desktop here. Booyah. Lots of booyahs tonight.
You could put him on his back and do some sort of crab walk and see if that works with his arms.
Hold on, I'm having some mouse
Let's try it.
issues. There we go. I had to move my USB receiver for the mouse a little closer. Okay, so close. Well, actually, we'll save this project for fun. We'll call it Arduino test wheel encoder. Okay, so to make a plugin, this is the fun part. So we already know our code we think works, in quote, quote. So let's shut this down. And Easy Builder, we'll close this down too, because we can always come back to it. And we don't need this anymore, this web browser. We'll come back to it if we need to. Okay, so actually we do need it, because we need to create a project on Cynthium. So go to Software, Manual, and we're going to create a new plugin. So if you actually clicked on related tutorials, it'll tell you all about how to create a plugin. You can follow through this. This is actually a pretty good guide. But what we're going to do is we're just going to click right into it and go create behavior control. Boom. Give it a name. And the name we're going to give it is Arduino Uno. Actually, it doesn't be Arduino, because it could, technically we can use this with any other firmware that it's adaptive to, right? I don't know how I got my exact setup Arduino. I'm going to try it with Luan. You know, Mark, I don't know, what's the baud rate of the Luan servo? Do you know? If it's 115K, like 115200 or less, you'd be able to do it. But if it's 1 megabit, I don't think you're going to have luck with your Arduino Uno. You can do it with a Mega. So we'll call this Arduino Uno. Actually, we'll just call it wheel encoder counter. Oh, if it's 115.2, you should be okay. So we'll put a description here. This control is compatible with firmware that counts wheel rotation and for left and right wheels. Done. That's good enough for now. Click save. And we have the ability to upload pictures and stuff. We don't need that now. What we really do need is this plugin XML. So before we download the plugin XML file, let's create a plugin in Visual Studio. So once she's loaded, file, new, project, and you want to make I don't want to make a Windows format, but I usually like to make a class library. That way you don't get like all of that extra stuff added to the like DLL libraries and stuff that you don't need. And I'll show you why that matters. So I'm going to put this inside of my plugins folder. So you got a lot of plugins I've been working on over the last while. And I'll call this Wheel Encoder Counter. And make sure your firmware is set for 4.6.1 because that's what all the plugins use. Okay, so because this is a class project, it loads a class right away for you. We can close that down. And you'll see here, it doesn't add very much, which is nice because we don't need a lot of things in here. Like we don't even need system.data, stuff like that, but or system XML, because we're not going to be doing any of that, but we'll keep it. And we'll just delete the class. And then what we're going to do is right click and say add, and we're going to add a new Windows form. This is a real quick way of just turning this into a Windows form without having to have all of the extra libraries added. So we'll call it form main Windows form. Click add. Cool. Okay, so we'll close this window form down. We don't need it right now. Now we have our references. We want to add a reference to Easy Builder. So as you can see here, when I click browse, I already have a history of all the things I've used, which is Easy Builder's in there, right there and there. But I'll show you how to get to it yourself. You click browse, go to your program files folder in your C drive, go to Easy Robot, Easy Builder, and select Easy Builder. And also you can hold down the control key and select Easy BDLL, because you need those two. And click add. And say okay, okay. I'm going to make all my buttons say okie dokie instead of just okay. So then when you look at these, you notice here it says copy local equals true. And if you click on say system, it doesn't copy local. That's good. We don't want these to copy local. There's no point for when we have a plugin to copy all of Easy Builder and all of EasyB with it. So we're just going to select false from here. And same with this one. There we go. So neither of those are going to get copied when we compile the program. Okay, so now back to our website. We have this plugin DLL file that we're talking about. That needs to be included inside of your plugin so that Easy Builder knows what it is and what it's going to be looking for and how to load it. So we'll click download it, and there it is. So what I'm going to do is I'm going to copy this file and go back to our application here and paste it in. And there it is. Now, if you look at its options, it says do not copy. Well, we actually want to copy this one. So copy always, copy if newer, it doesn't matter. If you really, really care about that extra one bit of disk copying performance, say copy if newer. I don't really trust a lot of what Visual Studio does, so I have it set like to copy always. So next thing, if we double click inside the plugin, you'll see here that we have our description we created, and there's a DLL file name which is empty because it doesn't know, and we have to actually fill that in. So before we do, let's grab our GUID and let's configure this project to compile itself into the folder that's named by the GUID. So we'll go into our Explorer, and I already have a plugins shortcut here, but it's actually in users. public, and public documents, easy builder, and plugins. And then in here, all the plugins you've already downloaded in the past will be there, as well as the one you're going to create. So we'll just click new, and there it is, and we'll just paste in our GUID, and we'll go into it. And there's our URL that we want to compile this to. So we'll copy this, and then we're going to tell this program to compile itself and output itself right here into that folder. So we'll just paste it in there. And then we want this to be set to x86. It doesn't have to be, but it's a good idea to have it set for that. And next thing we want to do is we want to tell it when we actually go to debug this plugin, we want it to launch Easy Builder. So we can specify the startup external program, and we'll go into our Easy Robot folder and select Easy Builder. So when we actually click debug, like compile and debug, it'll launch Easy Builder, and it'll allow us to debug and step through any code. It's a really nice feature of Visual Studio. Okay, so next thing is a category type. By default it's beta, because we're in beta mode. Let's put this in, I think this is like a navigation type feature, so I'll throw it in there. And this will be our release number 1, and then a DLL file name. Well, we don't know what that is yet, right? So let's compile this program. We'll just do a build. And then we'll look inside of our folder, and there it is, wheel encoder counter. So we'll just copy this name and throw it here. Sweet. The good thing is, like, if you have a space in here by accident or things like that, when you actually go to upload your plugin to the website, it'll scan this file and actually check to make sure that everything's hunky-dory before. It'll give you a message too, so it's nice. You can't really screw it up. Okay, so if we look at our main form now, this is what it looks like. Let's go to the code for it, so we can right-click and say View the Code. And we want to tell this form that it's not a generic form, right? So this is saying this is the name of your class, right? So we called it form main. We could have called it anything we wanted. We could have called it, like, I don't know, okie dokie if we wanted, but we call it form main. And it's inheriting another class called form, which is what makes it look like a form and operate like a form for Windows. We're going to make this operate like an Easy Builder plugin. So we're going to erase that and change this to Easy Builder, UC Forms, use Form Plugin Master. There we go. Now watch, when I click on the form now, look, it's going to change. See, it's white. This changed. It's got a question mark, just like all the Easy Builder controls. It looks like a Easy Builder plugin. So, a couple things we can do on here. We just want to test this and see if it works. So let's just put a button. And our button is just going to be get wheel values. Okay, just so we can actually see them. And we're going to throw those wheel values into just a text box. There we go. We'll make this a multi-line text box. There we go. So what we'll do is every time we push this button, we're going to write the wheel values in here. So let's shrink this down. And we got this wheel value button. So if we double click on it, click, click, it's going to create an actual event. This is the event that will execute whenever the button's pushed. So in here, we're going to actually write our code that's going to talk to the Arduino, and it's going to grab its data. So first thing we probably want to do, actually, which is kind of interesting, is we want to make sure that this control that we just made is connected to a device which has the capability of actually checking for a wheel encoder, right? Because in EasyB doesn't, but this Arduino does. So let's say if, we'll go to our EasyB manager here, and we'll grab our first EZB, and we'll say firmware, and we'll say capability, is capability supported? Capability required.
Hello, hello.
I think I think capability required is a good one, but because it'll throw an exception. So maybe we'll just do that. And then we'll grab our capabilities, which is from EZB dot firmware dot capability, and the capability we care about is some sort of wheel encoder. There it is, wheel encoder. Alright, so if this is not supported, alright, oops, is capability supported. There we go. Then we'll throw a new exception, and we'll say the connected device does not support the required capability to count wheel encoding. Right. So what this just did is we actually just checked to see if whatever's connected, whether it's an EZB or an Arduino or a microbit, can it actually count? And because we made our own firmware, we actually know our firmware can do that. So we'll put this inside of a try. That means if there's any errors. And then let's log the error to something that we can actually see to that window. So we'll use, here we have a bunch of commands we can use inside of EasyBuilder. So let's use EasyBuilder here. That way we can do this. And same with EZB. That way we can get rid of this. Oh no, we can. Oh no, we cannot, because EZB.firmware is actually a thing. There we go. So now it's log invokers dot append text to the text box, new line, and we'll just throw in the message in here. There. Invokers is nice because what it'll do is if we copy this code later, it'll actually allow cross-threading system calls, or like whatever you call, to an object that doesn't support cross-threading. So a text box won't, till append text won't. So if you look at invokers, check this out. There's a ton of stuff in here. Colors, buttons, everything you need. It's a very, very nice. The other option, if you didn't want to use an invoker, which you can do, which is convenient as well if you wanted to put a bunch of stuff in there, is to say grab the text box and say invoke a new action.
That did sound robotic.
And then put it in like this. There we go. So this would actually invoke whatever's inside of these brackets
So we can make
under the thread of this particular object. So essentially what's inside of here is the same thing I just showed you, but we'll do it like this. Okay, so check if the capability is there. Next, we want to see if we're actually connected to an EZB. I don't think it really matters, because as soon as we go to read from it, it's going to return an error anyway. So let's not even check if we're connected. Let's just grab our response. Response equals ezbmanager.ezbs.send command. And send commands are really nice because it'll talk to an EZB, whether it's your TCP, it doesn't matter. It doesn't matter what kind of EZB it is. It'll figure its stuff out. So we have how many bytes to expect and what bytes we're going to send it. So we're going to we expect to get back. Now remember, if we look at our code, this gets both wheel counts, and it's 2 times 16-bit, right? So, and you get essentially we're going to get back, right? 2, which is going to give us, this is 2 bytes, and we're going to get that back twice. We're going to get back 4 bytes. And we're going to get 4 bytes back for all these. Except for this one. We get nothing back.
do something with the sword.
Zilch. 0 bytes. 0 byte. And so we want to get back 4 bytes. And the command we're going to send it is 0x00, right? 0x00, and then we're gonna send it this one here.
Interlock the lines.
There we go. 0x00. Here's our response. So now what we can do is we can parse the response because we want two unsigned integers at 16. Oh, wait a second. If we look into our code, was our code unsigned ints? Do you remember? Let's take a look. Because it might have just been ints, in which case, documents, Arduino, easy Uno. So we want to make sure that it's unsigned ints. Dun, 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 dun. So, I don't know, a lot of you guys probably know the program. Those who don't, unsigned, like an uint versus an int. So, let's say a 16-bit int, right? It can count up to 65,536, right? Different positions, which is actually that number because 0 is still a position. And so that's the maximum size of a uint, right? Unsigned. As soon as you make it signed, right, like this, that means is you can actually have a plus or a minus next to it, but you can't, because of the amount of space you have, you can't actually count positive 65,000 and negative 65,000. So it's 65,000 divided by 2, right? Which is size, I don't know, it's like 35,000 or something. Size of uint 32. Oops, 16. Bum, 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 bum. I don't know, let's use calculator. Boom. So we'll go into programmer mode, binary, 1, 2, 3, 4, dun, dun. So 16. Oh, we're not in binary. There we are. Binary. 1. So 4, 8, 12, 16. So there's our 65,000. And we divide that now. Oops. It's the first time using the calculator or something here. What's going on? Programmer. There we go. Decimal. Divide by 2. 32,000. So if we were to set this up as a uint, or as an int, sorry, we'll only end up with a counter that go to 32,000, and we'll never use the numbers beneath it, so that's useless for us. So where is our variables we put here? They're in here someplace. There they are. Oh yeah, we created them as ints. So let's make them uints. What? There's no uint for Arduino? Come on. Oh, I bet you it's like uint 16t. There we go. Let's try that. Compile. Compiling. Wheel left, wheel right. It's not declared in our scope. What? What are you getting mad at me for? Are we...
I wonder if we can add an extra
UNs? Oh, unsigned. Oh my god, I am smoking so much crack right now. Look, that's why. Unsigned in front. Oh my god, how embarrassing. It was already an unsigned. Okay, so we don't have to put anything up there at all. So it's an unsigned uint 16. Now we have to parse it. So we'll get the left wheel. We'll use something called a bit converter. It's a really nice function built into C#, which allows you to grab a value from the response. Because remember, responses, this is going to return an array of bytes. See?
Right. What else can we say?
So this is actually an array of bytes. So we want to grab response, and we want to grab the first index. And because we're expecting an int 16-bit, 16 bits of data, which is 2 bytes, it's going to take 2 bytes starting at index 0
That effect.
and create a value. And we'll do the same with this. Right wheel, bit converter to event response. This time we're going to take it at position 2, right?
I'm
Set
the
position
universe defender.
And now we can use our invokers, append, put some value in the text box, true, and you can see these overrides here when I use the arrow keys. You care about this one. We're going to send some parameters. We're going to say left wheel, right wheel, and then we'll put left wheel as the value, and the right wheel as the value. Because these little placeholders, 0 and 1, are parameters that we're passing after this. So, left and right wheel. That's it. Our plugin should work. Let's try it out. So, we will hit build and our debug, sorry, and say start debugging.
Alright, anybody have any suggestions for what to say to put into Voltron? Let me know.
Cool. So it compiled, no problem. So project, add. Actually, we're going to load into our existing project we were just playing with, right? So let's grab that. It's saved right here. Arduino. Cool. So we can connect to it. There, we connected. And now let's go project, add, and plugins. And we should have our wheel encoder. There it is. We didn't give it a picture or anything yet for an icon. So now I can push this button. And it's queried and returned values. So it's actually talking to Arduino right now. So there's zeros because we haven't actually counted anything yet. So we have to set it up to count. So we can do that manually with some wires. So let's do that. Let me change my view here. There we go. So what we'll do is we're going to, so it's pulled up, so let's pull it down with ground. So we'll put this into the ground pin here. And we're counting pins 2 and 3. So I should be able to just put this into 2 a couple times like this. Maybe I won't even put it in 3, I'll just put it in 2. Okay, and now let's take a look at our desktop. Look at that. We counted a lot, 419. So it counted real quick because we were scraping the metal, right? So it was every time the value changed. We didn't do anything in the right wheel, as you see. So if we go back to our close-up here, and let's do the other wheel, which is pin number 3. So that's the one next to it right here. We'll just tap it in there a few times. I feel dirty doing that. And let's go back to our desktop here and click get wheels. There we go. So by scraping it like that, look how quickly we went. Nice. So we have a wheel counter. So if we had this on the robot, we can hook it up to a servo that had a built-in, not a servo, sorry, a motor that had a built-in wheel encoder. We can count the rotations. Okay, but we have some other parameters right here, right? Get both wheels and reset, and there's this one too, reset wheel counts. So let's add those two. So we'll click File and save this project we're working on. And load it back. And so let's now take this button and copy it. And this one will be get wheel values and reset.
I get new on this whole website. It's weird. For sure.
And if you use an ampersand, you have to put it in twice. There we go. Cool. And then we have another button, which is just reset.
Oh, it says they're 7.4 volt compatible.
Reset values. There we go.
So you can feed them a
Okay.
2-cell like
So this one here, let's essentially we'll do the same thing. We'll just copy this code
Interesting.
and
Alright, anyway.
rather than send it 0x
What else can we do?
000x00,
Voltron's parts.
we're gonna get both wheels on reset, which is this one, 0x01.
See here.
So we'll make this last one a 1. And here's our response.
Good, start painting Voltron. I do have some paint that I brought.
I thought I heard DJ is my father. Hey, it's up going, Keith. Last time, I think it was last week or the week before, Keith, you said there wasn't enough software programming, so we're doing nothing but coding tonight. Oh yeah, we made firmware. So Jared, we made a firmware that counts wheel encoder
Oh,
for the Arduino,
that's pretty
and then now we're making a plugin. Did you miss anything, Will? Yeah, you missed everything. So we can count wheel encoders. So right now what we're going to do is 0x01, and then we want to make the next button here, reset values. So Will, what we were just doing, as I was just saying to Jeremy, is we made a firmware, custom firmware for the Arduino, and we have it set up so that it'll actually count wheels, the wheel encoder values. And then I'll show you, we'll actually hook it up to some wheels and we'll show you how the wheel encoders work. And then we're making a plugin right now, which looks like this, ugly looking plugin. And this plugin will display the wheel encoder counters values. And then what we'll do, we haven't got there yet, is we're going to set it up so that the wheel values will run as, it'll query it in a timer, and it'll set the some variables so you can use it in easy script code. Okay, so this button that we're editing right now is called reset values. And reset values uses a protocol value number 2, right? If we check here, reset is number 2. And it doesn't return anything. So we want to go back and turn this to a 0. And we can get rid of this because there is no response. We can get rid of all this. And then instead of this text here, we'll just say resetting wheel values. Booyah. So let's run our program. And we have a project that we created here called Arduino Test Wheel Encoder. So we'll load that up. And we'll connect to our new Arduino with our new super duper firmware. So you can read here what kind of firmware it says it is. And now when I push get wheel values, there's our values, right? That's where we last left it. But when I push this button, it's going to return the same numbers, and then they're going to set back to 0. So when I push it, there's our numbers. If I push it again, they're all going to be 0. Cool. So let's go back to our close-up of the Arduino, and we have this grounded off. So it's on pin number 2 and pin number 3 is our interrupts for the encoder. So I'm just going to simulate them by going like this, just poking these pinholes here until, there we go. So that should give us a huge number of counts. So now we go back to our software, and if we click on this button, there's our values. Click on this button, it's going to reset it, which means that they're empty again. Sweet, it's working. Oh, we have to test our reset button. Let's do that first. So back to our close-up. And let's dun, 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 dun. See, my Friday nights aren't that bad. There we go. And now let's go back to our desktop And if I push this button, we'll see the wheel counts. But if I push reset, and then now I push this button, they should be zeros. Yes, they are. Sweet. Okay. So next thing we'll do for the plugin, just so that we can publish it and make it so you guys can start using it if you want, is let us put this into a timer, so it'll run on a timer. And what we'll do here is we'll keep these buttons, but we'll make it so it sets these values into a variable that we can use. So let's close out of here. And here's our ugly little control interface we made here. So let's add a panel. And we'll put these buttons inside the panel. And then we'll set this panel to dock on the top of the control. There we go. And we'll put these up like this. And something else we can do is, I don't think we really need this too much, do we? Yeah, we'll keep it. Let's dock it to the whole window here. And then we'll give it a scroll bar so people can scroll if there's lots of text in here. Scroll bar, there you are. And then we'll make this window smaller since it doesn't need to be so big. That's what she said. There we go. Okay, so I think the next thing we want to do is we do want this thing to be able to run as a timer like I mentioned. So let's put a checkbox there so we can control the timer. We can have it controlled over using script. So add a toolbox checkbox. And we'll just put in here some text that just says query or update every 500 milliseconds. Actually, every second is fine. 1,000 milliseconds. We'll put 1,000 in there so we can sound smart. And if you probably haven't noticed, but I haven't been given any of these objects names. There's like button 3 and button 2 and stuff. Don't criticize me for that. I sometimes go back and I'll actually rename things. I used to really be like I used to make sure that I named everything. I was very disciplined on that, and then over time, now with refactoring, I don't have to worry about it as much. So, for example, refactoring, what that means is if I go into here, I can just rename it inside of here, right? So I can call this button reset values. But if I double click on it, you'll notice that it still hasn't changed this because it only changed the name of the object. So what I can do is I can click on here and I can Control R twice and I can actually rename it. So button reset values underscore click. All right. And then I can do that with all the other ones. But I'll end up doing that later. I'm not going to do it now. Okay, so we have this little checkbox. So we'll make it so we can double click on the checkbox. Double click. And that way, whenever it's changed. And we have to make a timer. So let's make a timer. Now, there's two types of timers. A lot of people, when they program in Windows Forms, they get lazy and they just type in timer. This is a very safe timer for writing and reading to and setting objects on a form because it runs in the same thread as the plugin, as the actual GUI. The only problem with that is if you run all timers on the same thread, it'll just every time the timer runs, it'll lock up the whole UI for everybody. So that means every control that's running will just lock up. So you want actually to use system.timers.timer. This is this timer runs as its own thread, which means that if you're ever going to do anything within the timer event that manipulates the GUI, you want to do that inside of an invoke, which we talked about earlier. So
So right now it'll be
here's what we'll do. We'll say timer equals new
server horn.
timer dot
Mounting your
lapsed. We'll create a new
threads for
and
this
timer
server
dot
and
interval
the
is
brackets up,
1
hold on
second.
a lot better.
And we're not going to start it though. Okay.
Sometimes 3D printed plastics.
Timer dot. I don't think there's something we have to set in here to make it continually run, like an auto reset. No, those values are all fine. Okay, but we're not going to start it yet. We'll take this piece of code, and now that since we have a timer, we want to shut the timer down when the form goes away, so when somebody closes the plugin. So we click on the plugin, we'll go into our events here. We're going to say when closing, and this is going to create a new event. And just for organization, let's put it up here by the, this is the initialization, and this one here is our closing. So we're just going to say timer stop, timer dispose, that just helps the garbage collector, and timer null, which just say garbage collector, you must do this. And we're also going to create a value in here called is closing, which is a, you'll see what we're going to do with this, though, but we're going to set that here, is closing equals true. Okay, so when the form is closing, when the plugin is closing, it's going to set all this. The top of elapsed, we're going to say if we're closing, get out, and GTFO, that's what we're going to say here, because we don't actually want to run this, because what will happen is Windows, because it runs in multiple threads, you're going to click the X button. Meanwhile, while you're clicking X and while the plugin is disposing itself, the timer might still run, and then it might try to write stuff to the screen. So this is safe to do. Or you can put in a try catch as well, and we'll end up doing that in a second. So we have these buttons. This button does, we should put some, so this is 0x00, which is, I believe it's just read. Yeah. So let's grab this, and let's make a called read values. There we go.
So this servo horn doesn't have any plastics in it. Took them out.
And then this one is 0x01, which is read and reset. So we'll grab this. Read values and resets. And then this one here is just reset. Plain old, boring, but awesome reset. Values. Clickety click. Reset values. Nice. Cool. So now in here, a timer, we're going to do a read values. Because we're not going to read and reset, because every time it runs, if it resets, that's going to be crazy. So we can just expect the person to be able to reset it themselves if they ever felt like it. And when somebody runs this here, we're going to say if the CB update is checked, start the timer. Otherwise, stop the timer. Right? And can we check if the timer is running? I don't think so. No. We'd have to create our own override for it, I think, if we wanted to, but if you don't want to run it twice, I don't know if you can start a timer twice, but this won't do it anyway. All right. Dun, 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 dun. There, so that our checkbox will query this each time. And what we'll do when this is done, we're going to have it set the value that it just read to easy script. So we're going to go easy builder. Actually, I think it's just scripting. No. Easy builder dot scripting dot variable manager dot set the variable value. And we're going to call this one left wheel encoder. How about just left wheel count? That sounds good. And we'll put the left wheel number in there. And then we'll do the same for the right wheel.
Pushed it down until the threads just disappeared. Those
There.
disappeared.
And
That should be fine.
alright, see, trucks.
And then I'll split out.
And then we'll do the same. We'll copy this code here and we'll paste this into the values and reset as well. Sweet. So now we run our little program here. We should be able to watch the values move in real time, or every second if that's real time. So let's add a variable watcher under scripting.
This camera so you can see over my shoulder here.
There we go. Oh, look at that. See the value that we want to set, like if I push this button here after we connect, if I click this button, you see it added those variables. We want to add those variables when the plugin first loads so that they exist, even if they're the value of 0. So let's go to override set configuration. So this is whenever Easy Builder says, hey, you should configure yourself with something. We don't actually have a configuration, so we're just going to leave this as it is, but we're going to take these two parameters, put them there, and set these to 0. So at least they have something in them. Alright. So back to our project, connect, and let's add our variable watcher. There we go, look at that. So there's our variables. Let's save this project. And when I push this button, get wheel values, they are zeros. Okay, that's fine. So what we can do now is we can click on update every 1000 milliseconds, every second. And watch, we're going to see this thing continually climb. Now what I'm going to do is I'll switch cameras. And I'm going to ground out 2 and 3. And we should see those values counting. So let's take a look here. Let's go back to our desktop. Uh-oh, except for our left wheel count and our right wheel count seem to be the exact same number. That's not right. Did we? Oh, look at that. We put the wrong value in here. Okay, so let's just stop our debug here. Stop debugging. Right wheel. And we also have to put that in this one too, right wheel. All right, debugging is useful. Cool, okay. So now, even though we have it set up so that it queries and runs on its own through a timer, that's cool, but let's also make it so that people can tell it to update with either a control command or an easy script command. So let's do a control command. Let's just have a control command that says update the values. So what we're going to do here is we want to, we'll do it right here, do an override on get supported control command. So you know when you right click in Easy Builder when you're editing and it gives you a list of all the, when you're editing a script and it gives you a list of all of the control commands available, it queries every control, and this is actually how this control will respond and say, this is what I can do. So we're going to return a string array of parameters. So this one will be called, we'll just call it, oops, what do I want to call it? I'm going to say auto refresh, start, and auto refresh stop. And then we'll create another one called get values, another one called get values and reset, and a third one just called reset values. Now, I'm not doing great programming example right now because we're going to be using just plain strings. Normally you want to put these inside of an object someplace. Like say read-only string, maybe even make it static and just say command auto refresh start, and then put this in here. And since Keith said that he's got students that watch this, I'm going to probably get criticized for not doing this, so I'm going to do it now. Auto refresh stop, read only string, command get values, read only string, command get values and reset. What's the name of your sex tape, Jeremy? Command get. Oh, this one's just reset values. There. So now, as you can imagine, I'm going to get rid of this and put command. Oops, that one's already there. And we'll put this at the top of the file. Up here. Boom. Oops. Boom. Oh. Did I not copy and paste it? Where are you? There we go. Let's get back in my clipboard. Sweet. So now these are hard-coded, so we can't screw them up, we'll say, in code. Because the next thing we're going to do is we return them. The next thing we're going to do is we're going to override another object, which is called do command. Do control command? On control command? What is it called? Do you guys know? Command? Send command. That's it. I almost had to look inside of the manual for a second. So what we want to do in here is we want to actually handle each one of these. So we just want to say if the window command that came in, if it equals, and we'll do start first, and we want to make it an invariant case because we don't care. And what we're going to do here is we're going to start the timer. That's it. And then else, we'll copy this. And we'll change this to stop. And if you guessed it, we're going to stop the timer. And then, what's our next command? Command get values. It's an easy one, right? Read values. Next one. Command values and reset. All right, read values and reset. And lastly is our just complete reset. Oops. Reset values, right? There. And that's it. And then finally we'll do an else. And an else we'll send it to the base. That just means whatever called it, we'll let it figure itself out. Actually, I think this throws an exception, so. And then that gets handled and it says, hey, there's no actual command. Control, because if you pass a control command called like banana for some reason, it's not going to get caught with any of these. It's going to error out on here, which is what you want. Okay. So, yeah, man, that's it. I'm a little worried about the fact that we're writing the data that we read to the screen so much. It just seems like a lot of useless data, especially since there might be a lot going on in the project. So let's be friendly to the users. Let's add another checkbox. And let's put a debug. We'll put a debug property into this. Debug. Okay, that allows we can control what's actually being displayed on the screen, so we don't have to keep updating the screen every time we read. So we'll say CB debug, and we'll go to our code with F7. So right here, where we write to the window, we'll just go if invokers dot get checked value CB debug. CB debug. It's a Bee Gees song.
We played this for a while, so maybe I'll just move the camera to show you what's going on over there.
Boom. And boom. There. So we're only going to write to the checkbox or to the text box every time the debug is checked. And if we wanted to get crazy, we can control the debug values with this. So let's go up here and let's do that. Let's get crazy. We'll make this debug on and debug off. Command debug on, debug off. And then we have to return them here. Command. There we go. And finally we'll handle it here. Command debug off. Okay, so we want to run our invokers, set the checked value of the checkbox to the value of false, and then we'll copy all this and make this one on. Maybe it's not that's true. Oops, debuff. if you got to debuff it, this is the command for you. Looks like we have to do a, there we go. Debug on, debug off. Sweet. Okay. That is it, guys. That's super cool. So there's a little control we made, a plugin. Let's run it. Let's test it. We'll upload it to the website. We'll put the firmware online. So let's play with it first and make sure it works. So we're going to connect to the desktop. Connect to the desktop. Connect to the firmware. To the Arduino. And we can go project add audio speech recognition. There we go. And let's edit this. And let's add a command called show me the values. And we can go to our code here. We can right click. And there's our wheel encoder counter that we just created. And check it out. There's all of our control commands we made. So let's turn on, when I say show me the values, let's turn on auto refresh start. Okay. And then let's also turn on debug, because otherwise we're not going to see anything. Debug. There we go. And then we can say stop showing me the values. What we'll do here is we'll do the complete opposite. We'll stop it. And debug can stay off. It's fine. There we go. So everything's turned off right now, so I can say show me the values. Check it out. Oh, we're not turning the checkbox on now. Do you see that? Let's save this. And let's go back to our code, because inside that control command, we want to actually give the user some notification that the checkbox has been flicked. So refresh start. We're starting the timer, but that's all we're doing. So it's invokers, set checked, CB update, true. And then we'll put that also in here as false. Booyah. Let's load our project. Connect. Okay, here we go. Show me the values. So we turned it on and we're debugging, and there's our values. So I can grab my my little wire I have set up here and start shorting out. And look, right wheel is counting up. Do you see it? And we'll go to left wheel. Left wheel is counting up. Cool. And then we can add another command in here called clear the values. And we might be able to do it actually from Blockly. If I click into utility here in Blockly and add this control command, there's our wheel encoder and there's our reset values. And if we look into easy script, that's what it created for us. So it's running. Okay. So we'll say, stop showing me the values. It stopped. Start showing me the values. Or what was it? Show me the values. There we go. And let's make it count. There they're counting. And then now let's say, reset the values. Sweet. Let's try it again. Reset the values. Reset the values. Oh, was it clear the values or reset the values? What did we put? Clear the values. I've been saying the wrong thing. Clear the values. Cool. Well, there we go. So now we actually have a, let's remove this. Wish we can keep it, it's fine. We have a new control created for Easy Builder. Wheel encoder. So let's add it to the website. So to do that, what we want to do first is we don't have an image. There's no icon. So let's go to the intranets. And we'll go to the website. I like to go to its flat icon. And in here we can type in, let's type in encoder. What do we get? Nothing useful. Let's type in wheel. Oh, we got lots of cool stuff. Maybe I'm boring, so I'll just choose this wheel. Car wheel. There. PNG, we'll make it red. And we'll download it. And we'll take it and put it into our project. You can't see this because it's hidden behind another window. But what I'm just doing is I'm renaming the file to title, and I'm setting it to copy each time. So if I build this project now and run it, and I go to project, add navigation is I think where we added it. There's our wheel encoder counter. Clicky click. So let's go to, we know, remember where we compiled it? We had this set to
Your English is very well.
to output someplace. Remember, we output it to that folder. So let's go to that folder.
I appreciate you.
3B.
English. Thank you for doing that.
There it is. So we're going to right click on this and we're going to add it to a zip file.
The unique builds that you do.
And now we want to upload this to Cynthium's website. So we'll click on our little icon here, go to my content, and behaviors. And here's my wheel encoder counter that we haven't finished. See, it's private right now. It's not incomplete. So you want to give it a thumbnail image, which we have. We'll get it from our plugins folder. There it is. And we'll save it. There it is. And then we want to give it an archive file. So we already created the archive file, which is a zip file. And we'll click save. Nice. Then we probably want to give it a better description as this too. This is compatible with firmware that counts wheels, left and right wheels.
Show you
We can also say,
ABS.
let's tell people that they can see this video. So let's just go back to the website, grab this hack session,
Yeah, well, they
and we'll paste it into here and say,
deflect
you
that.
can see how this plugin was created by watching my live hack event here. And we'll save this, and we'll set it for public. And if we go to the main page of the website,
Pull out for this again.
there's our wheel encoder counter. You guys can download it, but you can't do anything with it yet because you need the firmware for the Arduino. So let's do that. This is a part that you can't actually do, and I can't do it yet either because the website doesn't allow this functionality, but I have to edit under, let's see here, under this Arduino Uno, I have to edit this this piece here, and I can't actually do that. We have to do it in the database because it doesn't, feature doesn't exist yet on February 8th, 2019. So hopefully in another week or two, I'll be able to edit this easier. So that's pretty cool. I'm pretty happy that we have our first wheel encoder counter and Easy Builder.
Okay, what we're doing is we're taking this metal gear from a 360-degree metal gear.
All right. Any questions, guys? I'm gonna go grab a glass of water. You ask questions, I'll be back.
Right into this 30-point bracket because it makes them hold the circle up better and they strip less. So that's why we're doing it. Tricky part is getting it started, getting it positioned in the right place. And after that, it's pretty easy with just have to wait with the solder iron. Make sure the solder iron is back in order.
Ba-bum.
Usually I make a little mark, see where the teeth are at. I have to change the music. It's getting a little explicit over there.
Was it?
Yeah.
Good to hear. Need some more peppermint in your peppermint machine. Can you grab mine since you're so cheap with yours?
It must be running low. I put in 3 drops.
3 drops. Cheapo.
How much do you put in?
Way more than shit. But I buy that big thing of it.
I guess you buy it in bulk.
You're almost empty anyway.
Alright, we got it positioned here. Now we just need to put a solder iron on it. Melt it into place. This takes up to a lot of minutes sometimes. I could crank my solder iron hotter, I guess. And we melt it down till you can't see the teeth anymore.
Also, I think your peppermint is not very pepperminty. I think they might water it down. Smell this. That's one too.
Oh yeah? It's
Right.
very strong.
The color you like it, blue?
Yeah. No.
Yeah, it'll work with the Sane Smart Balance Robot It'll work with actually any wheel encoder at all. It won't matter what kind of wheel encoder, because a wheel encoder essentially all it does is just it's a small short, and that's it.
There we go.
So you just want to give it ground, and every time the wheel encoder passes by, it'll just make a count.
Alright, it's in there. I don't know if you can see that. But we'll pull it right out with our glove because it's hot.
Okay, now what did I say we were gonna do? Oh, I wanted to play with the Kinect in the Bioloid. That's what I wanted to do tonight. That's gonna be a lot of fun. Okay, let's do it. Let's do it. I'm excited. We have to make some changes to the Bioloid though, because somebody stole the battery for the Bioloid and took it home. And that somebody is a ninja.
A coding unit?
Cody Ninja.
Alright, see if this is start it in here. There we go. We'll melt it in place.
All right. Here's what we have to do in order to make this thing work tonight. So this thing comes with this plug for. Ooh, I never even noticed this, but you know the plug is just 2 black wires. What the heck?
I didn't notice, no.
Jeez. So 2 black wires. All right. Well, I have to cut these wires, and I'm going to solder a. Where is it? Here we go. One of those lithium polymer connectors to it, so that we can power this thing off. Proper lithium polymer batteries.
Beans plug.
The Dean's connector. Is that what they're called? Who is Dean? Some guy.
Famous guy.
Some famous guy who made a plug. I've only made like 100 or so robots, so
Actually,
I don't have anything named after me.
Dean's is a company.
Oh,
So-
Dean.
So it must be a last name of somebody then.
Yeah, I guess so. All right, so I guess I have to probe and find out what wire is positive, which one's negative. Ugh. Thanks, Robotus. Thanks for making my life so easy. Okay, so let's start by getting inside of this thing.
Cool. I'm betting my soldering iron.
Ooh, that went far.
Alright, let's make sure that is well positioned. Pull it out and let it cool off. Solder on here for later. Keep that
What kind of wire is this? What the heck? It's like rubber wire. Every time I go to strip it, it just stretches the wire. It's made like an old rubber boot. There we go. Korean wire, rubber boot, Korean wires.
Move it back over.
So I'm not thinking that I'm gonna attach them like this. It doesn't give me a lot of space to unplug them. That should be fine. Or maybe not. Hold on, let me go grab an Easy B so I can see.
Sorry about the wiggling. Get this back down there again. There we go. Start changing the brackets to the wolf
Dun. Let's see if there's going to be enough room for a battery connector. Yeah, it's not so bad. It should be okay. So which one's positive, which one's negative? Hey Jer, do you know which one is positive and negative in this?
Mm-hmm. Yeah, the negative is the
Oh, it tells me there.
nail.
Okay, sweet. Just gotta find out which wire is what. Ooh, it's pepperminty now.
It is.
Are you being careful with music in the background? Yes. Yes, we are. And Jeremy figured out today how we can get last week's video edited. So we should be okay. We should be able to get last week's video back online. Jeremy's magic.
Alright. So we're going from this
Cool. Alright, let's see if we can find out which one is what.
to this bracket. So you can see,
Okay. So this one closest to the magnet
see that there's
is the little plug with the dink. Dink plug.
about, yeah, maybe about a centimeter.
And dink plug is negative.
Actually, I need to trim this and hot glue.
Yeah. So this one here is negative. I don't recall having to ever do something like this with a JD, but hey, you know, I guess this is as plug and play as you get for other robot products out there.
Okay, that fits good, but it doesn't have any mount here anymore, so we're gonna stick some hot glue on the bottom and put this on. So that'll be attached that way. Hopefully it'll be
Wire doesn't solder very good. That's what you get for not having good lead-based solder. Is there flex core in this?
wire. I don't think you can get solder these days without flux core. Alright, there we are.
Okay. So this is a battery, and
Yeah, sorry if that's loud on your speakers, guys.
there we go.
Just
So
gonna
this
go fast
flat
and
one
this
is
way.
ground. Yeah, sometimes it's goofy with my soldering iron. If I think the plug is loose. Oh yeah, if I wiggle the plug, Jared, the light turns on and off.
Oh no.
Come on, Hacko, you can do better than this. I'll wait for it to heat up again because Hacko decided no heat for you. That explains why I was having such a hard time kitting this wire. I couldn't get it to 10, it was taking forever. Oh, that's better. There we go.
Alright. Snap that into place.
And to the top of this one, you guys can't really see what I'm doing, so don't worry about it. But it's something cool.
Okay.
Done. Okay, what did I say? Where'd that battery go? Negative was flat, like that. I'll put this in. Yeah, we said this one was negative. Should we double check? Tell Jeremy more glue sticks for Voltron. I think he's actually, his next robot he's gonna build is just, I think Jeremy's just gonna make a robot out of glue sticks.
Glue stick for gluey. Gooey, and gluey.
Let's try this again, make sure that we got, this is the right.
Oh no!
Did you break your...
I put too much pressure on it. I snapped my bracket. That took me forever to print. Well, let's do some welding.
Where did you print it at? Did you print it at like super fine or something?
Yeah, I did.
That's why. That's
I
what.
needed the precision on the gears.
So this one is this one, which we know is negative.
Alright, I'll show you guys something that I learned to do today. Some hot air and some filament. Bring you guys back over.
Hey Keith, you can check out Jeremy's other channel, but it's not very exciting. All he's doing is breaking stuff. Okay, so now we can connect. What's the name of his channel? Go to, it's called Bot Matrix Live Hack Session number 5. Go to the main page on Cynthium, on the website here, right here, and click on here, and then click watch. And there's Jer. Playing with himself a little bit, but there he is.
Adjusting, that's all.
Justin is Junks. Junk Juster. Cool. Okay, so we should now be able to power a Easy B from this battery. Or blow it up, one of the two. Let's see. Cool. But, thing is, these servos are not happy with 7 volts from a lithium polymer battery like this. So we have to give it more juice than this, but like I said, the other battery that was here for this robot was taken home by a Ninja, so we have to create our own connector onto it. So I'm gonna do something that you guys should never, ever, 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 ever do at home. Okay? Never, never. Disclaimer: never do what I'm gonna do right now.
Oh no.
So this, we keep a box of old batteries that have been naughty. And these are naughty batteries. Naughty batteries have been puffed out. So this guy's puffy, right? And puffy batteries are bad because they can light on fire. And you can make a battery really puffy by shortening it out. So what I'm going to do is I'm going to cut the connector off this battery without shortening it out.
What do I have here that can help? We'll just try this. So, what I'm going to do is mount.
So I'm going to use some electrical tape on each wire as I cut them off. So I'll show you what I'm going to do here, guys. Never, ever, ever do this. When the battery puffs out, throw it in the garbage. Don't do what I'm doing. So I'm going to start with positive and then tape the end up. And then take some more tape. Negative. Now you guys are probably like, what's the big deal? Well, you've never seen a lithium polymer battery explode before. it's pretty cool, but it's also quite dangerous. There. And now I'm going to put this back inside of Jeremy's little container of recycling bin of batteries.
You guys have seen, what do they call those things?
Okay, so
You feed filament into them, and you can like write with them, like a 3D writer pen, 3D pen.
oh, the 3D pen. Yeah, that thing didn't last very long, did it?
Yeah. This is like kind of like what the 3D pen.
Okay, so what we're going to do is I'm going to put a barrel jack on the end of this so we can power this robot from my power supply. So let's do that.
Take off some of the excess bits here. And hopefully that will be stronger than it was before. Lay that out a little bit. And then get my head out of the shop.
So once we get this guy powered up with some real voltage, I'm gonna hook up the Microsoft Kinect, and we're gonna make him dance. that's what I'm gonna do tonight. Teach him how to dance. It's not gonna be very good because he's gonna be mimicking my dance movements. You can see how good of a dancer I am.
Alright. Cool. Let that cool down and we'll do the other side.
Hey Jer,
Yes.
out of these 3 connectors on this, which one do you connect to?
So the last one here,
That's positive.
positive. This one is ground, and this one is the switched ground when you push it in. So
Okay.
usually I just tie those together, or you can leave it. Just do this one if you want.
Okay. So just leave it.
Yeah.
You know, we actually haven't used them since the weird stretching that we did last week. Keith is I don't know, I'm kind of proud of how far I got, considering I'm not very good at programming robot movements. Every time we've ever had a robot programmed to do something, Jeremy's always done it.
It's probably just because I have more time than you in the lab. You gotta do your CEO-ness. CEO-ness. I should say.
CEO.
I really did a number on this bracket.
See, people always make a big deal about soldering, like it's hard. The only hard part with soldering is trying to figure out how to hold the wires. Once you know that solder is just like melting metal to metal, the hard part is actually going to get the wires held into position so that you can hold them together. Alright, so I'll cut this piece off here because we don't need it. There, Jer, we never had one of these before.
Nice.
I'll put some tape around it so that we don't short anything out.
This PLA definitely cools off super quick. Excuse me.
I should got Jeremy to hot glue this with me.
Just test fit this on here. Make sure it'll fit. Melted it a bunch.
Okay, so if we did what we were supposed to do, and it's not going to blow up, we should be able to power him from ooh, weird. This connector is, there we go. Metal on it was sticking out. So we should be able to power this from my power supply. Huh. See what's going on with the metal here? That's weird. See if I can bend it back. That's better.
Cool, man. This is good. Take the melted piece.
Okay. Let's see if that will fit in there better. Hmm.
You can melt that a little more.
Kinda. Yeah, I've never had this happen before. This is weird. Oh, there we go. Looks like I did it. Okay. Next thing is give it some power.
Work on the outside as well.
And let's see if it blows up an easy beat. Cool, it worked.
I have successfully connected to your network.
Nice. So all we have to do is
Definitely looks like a help.
tape up this
So
wire.
melt it up.
Did I put the? Oh, I put the tape away. One sec. Uh-oh. I got the hot glue out. I'll hot glue it.
No one can stop you.
Where's the hot air? The cool air? Where's the air?
It's a little box beneath the
Oh.
stuff there. Oh. Let's see how it goes. We'll let that cool down. See what we can do. Hindsight, maybe I shouldn't put some glue on there. Made it
Finally!
too tough.
I had to steal the hot glue gun from Jeremy.
See you later, Andrew. Thanks for stopping in. Alright.
I have to get the hot glue gun back to Jeremy before he goes into withdrawal. Alright.
Next week I'll have 2 cameras instead of doing this all the time.
The one your camera stopped working?
Yeah.
Which one?
The one of that thing.
Oh.
So I have a frozen
Okay, here we go. So this is better than tape. Hot glue, better than tape. There we go. Give it our easy B. And we connect our cables
I have
to
successfully connected to your network.
D5 and D6, right?
I'm gonna drill again, so hopefully it's not too loud for you guys.
Okay, let's make it work. Anybody chatting online here? No, nobody loves this. Oh, somebody's commenting on this. I'm surprised it took a long time. I don't think anyone's even seen this yet, that you can run Easy Builder on a Raspberry Pi. All these like secret updates. No Twitter, nothing. We're not telling anybody. This is actually running, this picture is actually running, that's Easy Builder, running on a Raspberry Pi. Hey Marco, it's not my fault you're not checking out the website. What, Will? What are you talking about? Maybe you guys have to browse the website, synthium.com, more often. Yeah, check it out.
Yeah, these things that's
Hey, you like that, Tandy? I'm gonna get Easy Builder to work on this next time. That's gonna be my next Easy Builder project. Okay. Where were we here? Oh yeah, let's shut this down. Let's go into Easy Builder. Close this down. We don't need that anymore. Easy Builder. So the only thing about the Raspberry Pi version of Easy Builder is it does have a few limitations. You can't use speaker recognition yet. It's in beta, right? So there's a couple things you can't do, but give it some time. What? You ran Circuit Python on a Tandy?
Can you use the PyCam with the Raspberry Pi?
Can use I don't think you can use the PyCam yet either. I haven't. I mean, gotta remember we only got it running today. So if you check out the website here, we'll go back to the website. I'll show you something. I'll show you all something. Synthium. So under software tab, here's your different software you can download. Well, remember it is in beta, so there is less functional than the Windows version, right? You're not going to have that functionality, but you can still do plugins, just not all plugins. You're going to be limited to what plugins it can use. For example, any plugin that uses Win32 system calls, meaning like it's talking to the operating system, there's nothing we could do about it, right? Because with Mono, we're emulating all of the system calls that are being called through .NET in Raspberry Pi. You can also run it on Mac, and you can run it on any distribution of Linux that has Mono. So just on the website, click on it, and there's instructions. So you have to, on a Raspberry Pi, it's pretty easy. You just got to install Mono, have enough storage space for it. Untar the image that you download from us, and then run it. Booyah, off you go. So back to Easy Builder. So we have a project here we created called Bioloid, and I have to go grab it because it's in my folder someplace. Dun 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 dun. Bioloid. There you are. Cool. Okay. Thing is, when this Bioloid connected, it said, I am connected to your network. So I think it's actually connected to the Easy Robot network right now. I should disconnect it and connect it to... it should be fine. Let's find it. Which button is it? This button? There we go. 171. Sweet. 192.168. I got 171. There we go. We want to put this inside of AP mode and channel whatever 4. It's fine. Save. Reboot. Sweet. Oh no, what are you doing over here? Get over there. Okay, let's connect to the Wi-Fi's.
Oh no. Don't want that.
What's the metal board? I haven't seen that. Let's check it out. Meadow board. Meadow from Wilderness Labs. Professional grade runs .NET Standard 2. Oh, it's 2.0 only. That's not great for us because I don't think .NET 2 is very old. All right, from like 2005 or something. .NET Framework. Where's Wikipedia? There we go. .NET 2. Yeah, 2005. Its support ended in 2011 for it. So it's kind of strange that this new product on Kickstarter supports 2.0. It's weird. And they discontinued support for it 8 years ago. But whatever. It's still pretty cool, I'm sure. Let's check it out. So it looks like you have a bunch of analog ports, a bunch of digital ports. Cool, cool. It's plug and play, whatever that means to anybody who can solder wires to things. And you know what? I should get one of these, and we could probably add connectivity to Easy Builder through it. Especially since it's .NET, and if you find it easier to work in .NET. It's an STM32F7. Wow, it's a serious chip. An F7. 16 megabytes of RAM? Wi-Fi? Crazy. I can't believe they can... They compared it to a Raspberry Pi, which is kind of strange, though, because it can't really run an operating system, right? It doesn't have, like, a screen. It doesn't have an operating system. Join the revolution. Oh, my God. You know, remember in 2012, 2013, we started this whole the revolution with robotics? It's just...
I just screenshotted the
oh, my
same
God.
thing. It says the robot revolution is here.
We just can't avoid it now. It's like the revolution is everywhere. It's just every time I look around on any robot product these days, they're just like, join the revolution. Yeah, well, welcome to Easy Robot 2013, guys. Move on.
So sad.
So, can you buy this yet? Oh, Netduino.
So this is not gonna work.
Oh, these are the guys who created the Netduino. Interesting.
Brackets and stuff. Just
Hmm.
not on the stable yet.
Thing is, it doesn't run
So I'm gonna have to
an
look
operating system, right? So, all you're doing is it's essentially just like a microcontroller that you put code on.
both sides.
So you can connect this maybe to a Raspberry Pi, or you can connect it to a computer. Running. Hmm. You know which controller system you guys really got to get? Is a Latte Panda. I know they're a little pricey, but you just can't beat it. Because it's got a built-in Arduino, so you can put Easy Builder right on the Windows partition, and you can hook up. Marco, do you put the firmware for
So it's a set.
the Easy Builder on the Arduino that's on here?
The drawing board. Unfortunately, Voltron won't be finished tonight. I'm gonna have to. I think these brackets are fine. Just do it down here.
Nice. I think that would be like a killer combination. Is a Latte Panda with the Easy B firmware on it. That'd be awesome.
Forward.
I just don't know what the prices are. They don't really
Using these
tell
brackets.
you very much, eh?
I could
What's the difference here? This one's activated, this one isn't activated?
Yeah, let's do that. Let's use these brackets.
How much does it cost without...
I'll,
Oh, just show me a picture?
I'll slice
I don't want to
it
see a
off.
picture, I want to actually see it. How much does it cost? Give me dollar numbers. Amazon? Latte Panda. Just do it. Is this the right price? What's this one? Asus. Oh, what's this all about? 600 megahertz. What are you gonna do with 600 megahertz? Play Pong? 2019. What are you gonna do with 600 megahertz, Jeremy? 2 gigabytes of RAM or storage space or something. Let's read this thing. This is interesting. High performance quad core. The Tinkerboard features a rock chip something SoC. Requires rock chip video player in Tinker OS. What the heck is Tinker OS? Is it just some version of Linux that people just keep renaming? Oh yeah, Debian. I don't like that people just keep taking Linux distributions, putting their own name on it, and then their own GitHub repository, and then saying that they made an operating system. Like, Linus Torvald spent a lot of time building Linux in that community. They don't need to get it ripped off. 4 gigabyte for Amazon for 119 bucks. 119 US. This is Canadian for 121. That's not bad. 16 gigs. And yours has 64? This one here you got. No, that's kind of pricey. See, up here in Canada, we don't have a lot of options for things like this. I'll get somebody from our partner group to reach out to them, to reach out to Latte Panda. I think they're owned by like DF Robot, if I remember correctly. I ran into them at Maker Faire last year or the year before, and yeah, they are, eh? Yeah, DF Robot. Here we go. Let's see if I can get them to send us one, and then we'll do it. I'll do a live hack with one of these. Look at this. What does this guy make? Steampunk computer? Just put a Latte Panda inside of an old box. Call it a computer. That's cool. How about we take a Latte Panda, put it inside of a robot, and call it a robot? Yeah. Okay, back to what we were gonna do. Let's connect to our Bioloid, and will he initialize? Let's find out. Cool. Everything worked except for this one servo. Man, this robots. And this servo doesn't work either. I wonder if it browned out. Let's find out. Yeah, those are the Dynamexels for you. Eh? Okay, there we go. Cool, seems to be alright. Yeah, these are Dynamexel servos.
Alright. Nice. They didn't stick out too the side. This is a bit offset, but oh well. We'll deal with that in software. Okay, good. One bracket down.
Cool. Now let's check our notes that Jeremy made for us here. So you remember this last week? We had to modify this servo here, which is 19, but the rest look pretty good. So let's get a Microsoft Kinect hooked up to this computer, and then we'll actually have the robot do what I do, following me with the Microsoft Kinect. That's gonna be fun. I've actually always wanted to do this. I never get to play with robots. That's why these hack nights are fun. It's hard being a CEO. Oh, Jer, how many volts is the Dynamexel like again? Will, you remember. How many volts is a Dynamexel AX12s like to have?
11.1.
How much?
11.1. Oh wait, are you talking about the
11.1? Okay.
X12s?
Yeah, AX12s.
Sorry.
Can I give it 11.4? 11.1. There we go. That works better. I was only giving it 8 volts before. Cool. Okay. Let me grab my Microsoft Kinect and let's do this. Doodle-doo-doo. Okay, here we go. Microsoft Kinect. So this is a 360 Kinect. I know that PTP's plugin will work with the newer Xbox, which for some weird reason I hear is called an Xbox One. Is that right? Yeah. Okay.
I have one.
So you have a 1-1. So this is an Xbox 360, which is the second Xbox, which not the third. Okay. I'll make sure you guys can read the Xbox 360 logo here so people know. It is a 360. Okay, so how am I going to set this up? Let me get a good look at the room and figure out what we're going to do here. Where should I put it, Jared? Connect.
Yeah, sure.
Like in front of the robot?
So.
So when I move like this and the robot moves, and then people can watch the robot move like this?
Yeah, for sure.
Okay. Okay, Jeremy has spoken. He says that I should keep the Kinect on the desk like this here. And then I'll stand off in the back and then we can use the 2 cameras. So I don't need all this wire then. It's not going to have to go very far. Oh, it's a lot of wire. Okay, so let's plug this in. And so we'll plug the Xbox. Jeez. It's like defusing a bomb trying to get this thing. How long is it set up to connect? Because you have to go to bed soon. You know what? You can watch it. It's going to be recorded, so you can watch it tomorrow. But it'll be another probably 10 minutes, I think, before we get the Kinect working. Once I figure out how to... Jesus, Murphy. Alright, so we're going to plug the USB into the laptop. If I can find the hole. It's the name of your sex tape. There you go. Okay. And some plastic over here. Okay. And so now I got the Xbox plugged in. Let's visit the website because I'm pretty sure we're supposed to do something. Oh, my mouse is not working. I think my battery's dead.
Okay.
Hold on. Oh, I guess I need... Are you guys using webcams for the camera? Seems like everything you guys are doing works just fine. Yeah, sure, Audi boy. I can let you know on the in the comments on the hack event thread. You can ask, and I'll tell you how many minutes it is into the video. Yeah, Will Huff. We're just using webcams for cameras. Like, here's the setup. Well, you can't see the camera that I'm showing you with this, but here's my microphone. And then I just have a monitor here running OBS. So you can see the conversation I'm having with you guys. And then this is my OBS. And I can do things like I set up different pictures for stuff that I can switch to. And then Jeremy's set up. Same idea, we just got these mics and put some cameras up in here like this. Yeah, it wasn't a very costly setup either. I mean, we just used an old monitor I'd lying around. I gave Jeremy my monitor from home though, because he had this little tiny monitor and he would like squint and stare at it. And I took it away from him, and he got mad at me. And he said, "Give me my monitor back." I'm like, "But look, I gave you this beautiful big monitor." And he's like, "No, I want my little tiny monitor."
Formed a bond.
He had Stockholm syndrome with the monitor. It was. Okay, so where was I? Oh yeah, let's go back to the website here. The only thing I'm not used to is having like a microphone in my face while I'm talking all day, all night. That part's kind of weird still. I feel like I'm on the radio. WKRP in Cincinnati. What was it? Wolfman?
Oh yeah.
Wolfman was on that show? Oh! You're riding with the Wolfman tonight, boys. Hope you brought your girls. Hold on to them tight, because I'll take them away. It's Wolfman.
Okay.
You're right, my name is DJ. I forgot. Sometimes I forget that I should actually be good on the radio. But I'm not. Sadly, they say. Okay, let's go into software, manual, and where is the Kinect? I'm suspecting it's under camera. Jeez, you know what? Maybe we should ask Amin to add a search function to this page, because there's so much stuff in here I don't even know where to find it. Maybe it's under miscellaneous? Oh, there we go, Kinect.
Switch my camera view for you guys.
Okay, this is the one I made. This is the one we want. So I do have instructions on this page, someplace. Here we go. You need to install some drivers, it says. That I can do. Download.
Just loading this building.
122 megs? What?
I hope it
Jesus, I remember like Windows 3.1 was like
see what happens.
10 megs, I think. And just the drivers, 222 megs? Man, these millennial programmers are using way too much data. It's like data is like free air, free water to them. There's no need for that much. Okay. I'm just loading the plugin. Oh, there we go, the driver. La, 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 la. I'll unplug the Kinect while this driver loads. Developer kit? No, I don't have to install a developer kit. I don't think so. Does it say so in this instructions here? No. Work in progress. Servo for legs are not implemented yet. Rotation servos are not implemented yet. The should rotation servos? The should. What's a should rotation servo? Maybe I'm supposed to mean shoulder rotation servo? Oh god. You know, every time we do one of these hack nights, I end up modifying and... Good night, bud. We'll see you on the forum tomorrow. Every time we do a hack night, I end up having to create new plugins and modify plugins. Oh my gosh. Okay. So, from what I understand, I should be able to just plug the USB back in this computer. And add the Microsoft Kinect plugin. Do I even have it installed? There it is. Looks like I have it installed already. Nothing's happening. I don't see anything here. Sitting position. Let's try this. Oh, look at me! I'm a stick man! Okay, so this works. Now we just have to configure the positions of each servo. So upper body. And then I guess we can play with the lower body servos. Maybe we can modify the plugin. Gumby, it did feel like Gumby. I felt like something. Like one of those happy wailing what are they called? The guys they put out on the side of the street. Happy wailing. I don't know. What are they called? Airmen? Oh, that didn't help. There we go. Wacky waving inflatable. This guy. That's what I felt like. Okay, so servo ports. Let's see here. Well, don't cry. It's okay, man. It'll be fine. You know, I should have put this. I'm just realizing now, like, I probably should have put these in some sort of image so you know where they actually represent. So this is left shoulder rotate. So I think that's ID number 1 on here. So V1 will select. Oops. V1. There we go. And then let's move its arms here. Okay, so this is down. And this is up. There we go. And then we have left shoulder, so that would be the up and down movement, and that one's number 3. So port number 3. So up. And this one is the other way. Okay. And then finally we have the elbow, which is port number, looks like it says 18. Oh, wait a second. Left. I'm controlling his... Is it his left or the left that I'm looking at? What do you think? I guess we'll find out. Like, well, you know, we could find out right now. Let's just go like this and stand in front of the Kinect and see what servo moves.
So, see him bouncing a bit back and forth. See the flexibility of this bracket. I'll do the next bracket and go probably. See, this is actually more stable now with this style bracket here. It's not as flexible.
Oh, it's seeing him. Look, it's seeing both.
He's seeing himself?
No, it's seeing
Oh,
this.
no way. The in move?
Oh my god. That's crazy. I don't know if you guys see that, but the Kinect is picking up the in move. So I think we have to make. Oh god, here's what we're gonna do. Here's what we're gonna do. Once we get this working, okay, we're going to make. We're gonna remote control the Bioloid, but with the in move. That's what we're gonna do after we're done. Okay, so I gotta move the in move out of the way first.
Crazy. Supposed to go with this. Adjust that leg a little. There.
It's still seeing this guy.
No way.
Yeah,
All the way back there.
yeah. Something's not right. Let's look at this again. Upper body, minimal value, maximum value. This just have to be inverted. Let's try that.
Okay, well, I guess we can start turning it off. There it goes.
What is going on? Okay, Will, I'll see you in a minute.
Oh yeah, I haven't checked on my chat window in a while. So
Okay, here. So 36, 41, Ooh, that's bending the wrong way too.
Okay.
Hmm.
Yeah, it's really flexing here and there. Let's see.
And also we got the smoothing value. I don't know what that is. Let's see what it says here. This value adjusts the smoothing movements, calculations of joints, and medium filter. High number increase smoothing. Okay. Let's not worry about that. Try it again. It indeed is the wrong ones. So these are backwards. So my right shoulder should be V1. And my left shoulder should be V3. And these ones, this is V2 is rotation. And this one is V4. Okay, that should be better. Now let's try this out. And then his elbow is V6. And then on this one, and this one is 18 is his. No?
That's a good step, actually.
18 is not working. Oh. Doesn't seem like it's plugged in. $18. Huh. Nothing's happening with 18. Let's check if we have it turned on inside of the auto position first off. Oh yeah, this is not even set up right. 18. V3. This one should be 18. Maybe we never saved the project last time. And then we have to go into the Dynamixel control here and configure this as well. Turn 18 on. Yeah, it's not set up. X12. Perfect. Let's save the project. Last time we must not have saved it. Let's see if that's working. Yep, there we go. You want me to scan with the Dynamaxes? I don't think I need to, because I think it's working. But for fun, we can do it. Boom. There's 18. So I think we got... Yeah, we got every other one correct. It was just, I guess, last week I must not have saved. Yeah, I love it too. That's a really good feature. It's a super good feature to be able to just push a button and scan and find all the servos. Okay, let's try it again, Mr. Kinect. Robot down.
Power supply stopped. Oh, because it's not controllable.
Because the easy B fell off. Oh no. Hold on, I have to, I gotta bend a plug back. Connector bent a little bit here. There we go.
Back to 1.
Oh,
2.
this pin bent on the easy B.
3. Oh, I think about 4. 4. 4 is on its way. 2.
There we go.
3. 4. Yep, okay, got that lean going. 5.
Okay, let's try this again, but let's not make him fall down. I think he's too... Let's have him crouch in a crouching position so he doesn't try to jump off the table this time. So connect to his Wi-Fi. Okay, so the standing position has him more crouched. Oops. What is going on, Kinect? I think it's picking up something. The Kinect is picking up something weird. My elbow. There we go. Okay. So I have him in a crouching position. So this time he should be better. Let's try this. Unpause. All right.
6, 5.
Okay, so I think one of the servos has to be inverted. It is this one here, which is that's his right, left. His left elbow. This one here. Invert that. There we go. And then let's also, it said something about smoothing, so let's set the smoothing to 20. That's what it was set for originally. Let's find out what happens there. All right, here we go again. Okay, everything seems to work fine except for
Always a
this one servo, this one here. It seems to like jump around when I move. Let me think. Why would you do that? Left, right. It says left.
sideways stuff pushes it. Yeah, there you go. Perfect. 5. Oh yeah, you definitely need to stay down.
Yeah, because for some reason this arm seems to just jump around. Jump around, Jer. The other one works great.
I think it is, yeah, just like too high up.
And then this one here,
See if you can balance him.
I want his arm to go higher, like that. There we go. And this one, oh, you know what's interesting? This particular servo that we're controlling right now, this one here, I'm pointing to in the little window, its numbers seem to be super backwards. Because when I go to like 139, it goes up. And this one goes down. And on this one, well, maybe not. No, I'm correct. No, I am. Look at this. This servo is backwards. Is there a way to to specify a servo direction if it's clockwise or counterclockwise? Because that's what I think has happened. There we go. Because his shoulder was upside down. That's why. Okay, let's try this again. Okay. It seems like there's some sort of math calculation incorrect with the left shoulder. Left shoulder calculation is incorrect. I don't think it has anything to do with the servo. So here we go. Shoulder left. Let's take a look at the code, shall we? Connect. Body control. Dun, 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 dun. Okay, so configuration, blah, 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 blah. Clip edges. So this is how it draws what the guy looks like. And skeleton sensor frame ready. There we go. So this is what we do with the actual data. So here we go. So we loop through the skeletons. There we go. Move servo. Elbow left. So we take the elbow left value. Let's find out what it's doing here. Get angle line between 2 points in degrees. Oh, J1 and J2. So J1 is the elbow left, J2 is the wrist. And then we're going the shoulder to the elbow. I think the wrist is working. I think it's the shoulder and elbow that is not. So I think it might be this one. Let's comment this out and run it again and see if I can get the wrist to, or the elbow to work. So let's just move his arm like that first. There we go. Okay, let's try it again. So his left shoulder shouldn't move at all.
Slightly adjust block 1, block 2. Honestly, it's not that high off the ground, but I might have to adjust this a little.
I was having a hard time trying to read what it was, the values were, but I think I know what's going on.
16 to the step. Step down.
I think I'll have to grab some water. On that metal board, it supports .NET 2, which .NET Framework 4 Plus is supported under that. Microsoft and all their .NET compliance. Oh, okay. Well, that's cool then. That's really good to know.
Foot in the air. So steps popped out. This is angle and turn. 3 is the step. 4 the weight shift. So then 5 and 6 needs to be step.
Boom, boom. So .NET. So they're saying .NET Standard 2.0. Interesting. So .NET Standard. That's right. .NET Standard. Like I didn't really quite understand what happened. They had .NET Framework, and Standard, and then they had Core. Is Standard and Core separately, or are they the same thing?
So I think that's what this tilt is. Maybe too much.
Angle and points of degrees. So we're taking. Oh, I bet you I have to do.
I think I like that better.
I think I suspect I know what's happening here. I wonder if we have to do an absolute on it to get the difference.
Just like 3 is the step, 6 has to be the step as well.
Let's try that.
So 2. This foot is a little bit further ahead. So 5. Make this foot a little further ahead.
Yes, of course. If I do an absolute, then of course it's going to do what we just saw it doing. But we know what the problem is, so we can fix it. So we have to determine which one is higher than the other. So just thinking out loud here. Because when we absolute, we lose our negative. And we now have no way to know if it was.
So it has to do with this servo. Going upward. And this leg popping out a little further.
My brain might be too tired now that it's 10:13 at night to try to remember and think what this is doing.
So is this servo adjusted a little bit? Yeah, turn it to see it then.
Dun, dun, dun. Oh, I might be able to do something as simple as just this. So rather than going from shoulder left to elbow left, just reverse these.
Okay, let's see what that's doing.
Right?
Okay, so we're going back to 5. On this side. 5. 6 has to be this guy moving up. And this guy moving up like this. Down.
Yes, that's exactly what I needed to do. I just had that wrong. So all I have to do is take this left, boom, move it to here because it's reversed. And then in our code, we just have to invert them. So there was a bug. There was a bug, dear Liza. Haha! We did it. That's cool. There we go. So the only thing I have to do is I didn't configure the elbows to bend upwards. So that's what I have to do next. Oh no. Oops, wrong way. I think I pushed that servo too far in one direction. There we go. Oops. Yeah, I'll show what I'm doing. Can you do the arms in front of you? Yeah, I could do that. It just doesn't do it yet. This is as far as I got. Oh. There he goes. Cool. Okay, let's save this and let's turn our smoothing down a little bit to 10. It doesn't seem like these servos bounce around too much, so we should be okay. Okay, let's try this. So it looks like I have his elbow is bending too far inwards. They don't need to go that far. This one here, like that. There we go. Okay, let's try this.
We were so close.
And I definitely have his motion exaggerated quite a bit as well. So we could turn that down a lot, it seems like. There we go. Okay, let's try this now. This is fun.
Big jerk. Look at me! Look at me!
You're the YMCA, YMCA.
Y M M
Yeah, there you go.
C C.
See, like,
Hey. I've never done the YMCA in my life.
it's like that. That's pretty good.
Oh, that's fun. Okay, so here's what we're gonna do. We're gonna put the in move in front of the camera, and we're gonna remote control the bioloid with the in move. Okay. Oh wait. Yeah, we should be able to do that. Let me see if I can get the in move working.
Oh, it's too much of a step. Oh, okay, I know why.
Do we have a power cord for the in move? What happened to it? Oh, there's something here. I see. Okay, I better pause this robot first. Cool.
Okay, let's save this and we'll see if we can do the walk. Start at 3. Yeah, the walk 1.
Okay. So, got our in move. Now I think I have an in move project someplace. It must be on my computer. Let me see. Let me save this project. And we're still running this as a debug inside of our control, a plugin. That's fine. So let's go open. And let's see if we can find it in move. Okay. This has a Wiimote. This doesn't look like something I want to use. Let's take a look at my files here. No, I haven't made anything in here.
We're doing it. We're doing it. It's walking. It only took 3 hack nights.
Hey, look, guys. Jeremy's got his robot walking.
It can be done. 3D printed robots. It's not perfect, but it's happening.
It's close. It's very close.
Very slow as well. But he made it from all the way from here to over here already. Yay!
Okay, so I'm pretty sure that none of the servos have changed, so all of these servo positions should work still. But I remember we made a project where I can use Wii controllers, and I can control the robot from Wii controllers.
Could step up the speed a little bit.
I might have to grab another computer. Remember that video
You saw it. You witnessed it. You watched.
that I did where I control the in move? Is it on the auto positioner? Do you remember? Easy robot in move Wii. Yeah. Okay. Do you remember what computer I used for that video? Was I using my laptop or was I using a computer that was on a table, like a tablet computer of sort? Because I think I have a project on that computer that I didn't save, and it allows you to hook up to Wiimotes and stuff. This is it here. This video here.
And you can speed it up a little bit more. And then turn down our delays.
Yes, you see in the background, I am using this computer. I have a project on that computer, so I can save it to the cloud and load it on my laptop. I know where that computer is. It's outside in the main area of the office. Okay, then go grab it. I'll be right back.
Who knew you can make such a thing? Oh wait. Board. You can get that done by it.
Okay, I got it. I got it. So, new project, open from the cloud. I saved it, and there it is. In Move DJ. Just for the version history. Ooh, I've had a lot of different versions of this project. But this is it here, saved from the office front computer. See? So the newest one is this one here. Boom. Cool. So we should be able to connect to the EZB on it. Oh, there it is. In Move. Okay, so this means I need to connect. Oh gosh, how am I going to connect the two at the same time?
Oh, there we go. That's what it is. This stuff is 3D.
I guess I can go grab the other computer and bring it in here. I was preferring not to. I was hoping to do it all on one computer. Oh, I can connect all the EZBs to the network. Or I can connect the InMove to the EZB here.
Okay, let's see what happens here.
That's what I'll do. So I'm going to connect to the InMove just temporarily. And I'm going to have it connect to the to this one here, EZB V4 DJ. Ooh, there's a key. 3Z robots. Maybe. Usually when we take the robot someplace, we always have to give it a name. Jerry, remember what we called the InMove password? 3Z robots? Easy robots, maybe?
That was easy robot 1, 2, 3.
Okay. Easy robot. Connect. Let's see if we can see it. Nice. That was it. Okay, so we want to go into client mode. We want this robot to connect to, what was it? Let's look over here again. EZBV4 DJ. EZBV4 bracket DJ. And there's no password. Save. There we go. So I don't know if you heard that, but it said, I have successfully connected to your network. So that means when we connect to the Bioloid robot now, we'll actually be connecting to both the InMove and the Bioloid. Okay, you guys following along? It's getting confusing. Here we go. Okay.
I am InMove, powered by SynView.
Oops, we don't want to do that. So we want to load a new project, load Bioloid, connect, and then we should be able to initialize, put them in a standing position. There we go. Okay. So this guy is now connected to EasyBuilder. Marco, no, you can do it with the EZB, older EZB model, but it's not going to work super well because the chipset on it and the driver is very slow, so it won't be able to keep up. So, okay, so we got the 4.2. So we have the InMove connected to the 4.2, or to the Bioloid. And what we'll do is we're going to... Oh gosh. We should have saved that locally. Or did we? No. No, we did not save it locally. So let's save the or the InMove locally so we could at least... have a copy of it to play with. In move. Yeah, you totally have to take it apart and install it. It's going to change your life. It's like so much faster. You wouldn't even believe how much faster the 4.2 is. Okay, so this is the project for the InMove. Now, all we actually really want from the InMove are the Wii controller and the auto position. That's all we need. Is this, and this. So what we're going to do is we're going to start a new project. And we're going to load the Bioloid project. And we're going to connect to the Bioloid. And then we're going to do a merge. And we're going to merge the InMove project into this one. So we're just going to move a couple of things, not everything. So InMove, there it is. So we're going to move in the auto positioner. We're going to move in the, I'm not sure what the init script is, so let's just move it anyway and see. We're also going to move the right arm and the left arm Wii remote. Okay? And the SS32, because that's needed in order to tell the, I think it's for the fingers only. So we don't really need it, but let's just do it anyway. And that should be good. So let's load that. There we go. So this is for the InMove. This is for the InMove. And this one is for the Bioloid, and this one's for the InMove. And it did say we loaded an init script. I don't see it here. Oh, it's on the second page. Here's the init script here. Let's take a look and see what it does. We moved some servo speeds. We set up a camera. We don't need this. Oh, we do. Left arm, right arm. We do something with this. So let's keep a few of these things. Let's get rid of servo speed. Let's get rid of this. Let's get rid of... actually, let's keep this auto position. Personality script, camera, virtual robot, speak, left arm, set D11. We don't need that. Okay. And then we have this SS32. And it thinks it's... The only problem with the SS32 is it thinks it's connected to the to board 1, which is the first Easy B. So let's get rid of this, because we're not actually talking to the Bioloid. And now in the auto position, we have 2 of them. So we want to rename this one to InMove. We'll call this Auto InMove, Auto P InMove. And it's using board 1. Okay? So now we can hit this button here and scan, and there you go. So this one here, C192.168.1.3, this is the InMove. So we hit connect. You didn't hear that, but we just connected to the InMove in the back. It just made a noise. And now it's complaining its battery's low. So we got to turn off the battery monitor for number 1. There we go. I'm going to save this project. This is a crazy project. This is Bioloid remote control, or sorry, this is InMove remote control Bioloid with Kinect. There we go. Okay, so now I should be able to move the InMove with this control here. So we go into it, and I'll initialize it into standing position. Okay, it moved. Here, let's take a look at the InMove. I'll turn the camera on for you guys. Ha. Okay, so let's move the in move. Let's make it move into this position.
Okay, let's see what happens when I turn that
Okay, this is great. Okay, so now we can control the in move with this. Let's also control the in move with the Wiimote. Oh man, this is getting crazy. So what I want to do is on the Wiimote here, this is the Wiimote for the left arm and the Wiimote for the right arm. Push save. So what I'm going to do is I'm going to configure the left arm and I'm going to specify its servos to be on board number 1 because the in move is on the second EZB. There we go. And now I'll do that with the y-axis, board number 1. And you know what's remarkable to think that I made this program? This is crazy. Board number 1. I didn't even think I could do this kind of stuff. And then we'll do it with this one, board number 1. Okay. Cool. This is exciting. Okay, so now I have to get some Wii controllers. So let's save this. Let me grab 2 Wii controllers. One second.
Oh, look at him go! Look at race JD.
Yeah? Is he moving quick?
We should have like a humanoid race.
Okay.
Wildoid versus Voltron versus JD.
So I got some Wii controllers here. And we're going to add them to the computer. So what we have to do here is there's a sync button you have to push. And then in the computer, let's see here, you have to... I think it's under join. This is the weirdest thing, but I think in order to do it, you have to select join personal network. Then you click add. Then you wait. And then you push the button on the Wiimote, the sync button. Or you hit A and B at the same time. That's what you do. And then it should show up in the list here. There it is, input device. Select. And no password. It didn't work. Try this again. There it is. This is a Nintendo device. Click next. There's a lot of RF in here right now. Come on, you can do it. Okay. Maybe I do have to hold this button down. Yes, that's it. You have to hold the button down and then it starts flashing. And then you double click connect. And then it's going to ask you for a password. And we don't enter one.
Yeah, let's see what that was. There we go.
Come on, Nintendo, you can do it.
Adjust that, but see if that's generally any good.
Didn't work. What? Why not? I don't think it's 000. I think it. Sure, there's no password on a Wii controller, right? It's just next.
Yeah, it's blank.
Yeah, it's blank. Just keep saying that didn't work. You didn't work. Do I have... I don't already have it added someplace in here, do I? See, hold on. See, Marco, check out this on the website. Under software, manual. Actually, you can just hit the question mark. I should have just done that, but miscellaneous Wiimote. See, make the Wiimote discover computer 1 and 2. Open, add devices, select it. Don't use a passkey. Yeah, there is no password on a Wiimote.
Remember we had to connect with that a different way? Remember that?
Yeah, we had to do something different with it last time we used it.
You have to use it through the settings, I believe.
That's what I got the. Remember, it was join personal area network. That's what we got this connected with. It just keeps going right away. Okay, let's try the other one. Maybe this one's just stupid. Take the battery out of it. Let's do this one. So add a device.
How do I fix that?
Well, that's weird. This keeps showing up as a device which is not the device we're connecting to.
Yeah.
Oh, see, this is working. Yes. Okay, we got one Wiimote working. That's good news. Cool.
Okay, that seems to be better. Save that.
Okay, one controller's done. So we should be able to select it from the list here.
Oh no.
There we go.
Wasn't better.
See? That one's working. Nice. Now let's add the second one.
Yeah. Not better.
Add device.
Falling back too much.
Hit the sync button. And wait and see if something other than this shows up. No, it's not a Nix Pro. It is this, but that one just doesn't want to work with it. I have another Wii controller. Let's try a different one instead. This one's just being stupid. Okay, so this Wii controller, actually I just got from Value Village the other day, because you get them cheap there. And, well, I got the whole Wii plus 3 controllers for like $30 or something like that. Yeah. I don't think that's what's showing up here is the right one, but let's find out. Oh, it says it's installing, but I don't think it's going to work because this timed out. 01. Let's see if this worked. No, it did not work. Okay, we can go back, do it again. Bluetooth is weird with Windows for some reason. Windows just has a real hard time with Bluetooth. I guess I shouldn't complain though, because Windows has been so stable for the last long time that if one thing's not going to work, I guess it can be Bluetooth. Motion control left, motion control right. Okay. Well, look at this. Another Nintendo controller is already added. I think that's the one we have to disconnect. There we go. Because this is the one that's working. This is the one that was not. It was in my list. It'll work now. So we could actually take these out again. And we can go back to this one again because it was added to my computer. It was just had to be deleted. It was remnants from another day. So now we click add, and then we hold this down. Where is it here? There we go. Select this controller. Skip. What? Oh my gosh, I'm losing my mind. Okay, we'll go back to this one. This is gonna be like an entire video of trying to add Wii controllers to the computer.
That's better. DJ, you want to see him?
Yes, I need a break from this because this is not gonna work either. All right, guys, let's take a look at Jeremy's walking robot. Okay, go for it, Jer.
Gotta give him a thumbs up. Alright, here we go. Got a rough start there, but we're good.
Cool. Way faster.
Walk him off the edge.
Nice work, man.
Trim. So he doesn't turn as much, but he's walking.
That's great. Voltron. Okay. Here we go again. So we're going to remove this. Dun, 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 dun. We don't have anything else that's in here, right? Music, router, some stuff, Logitech webcams.
We'll do the blazing sword. Got a
Okay,
sword
this is
shot
the.
action here.
No, it's not going to be the last time. I'm not going to give up until I get this.
There we go, sword shot there. Kung Fu grip.
Come on, you can do it.
Not if he dies red when he does it
You
again.
can do it, computer.
Maybe I need to make
Come on,
some sort of
computer.
for the sword at the back. I do have to put on his wings.
Oh, it keeps timing out.
Need to get some magnets.
Try it again.
I'll glue down here. And put some magnet on. Well, it's a happy day. We got Voltron walking.
You got Voltron walking. I can't get a Wiimote added to my computer.
Man, those things are the worst.
Like I'm usually the one who always demos it, and it works first time every time. It's like 7 years of using Wiimotes on my Windows computer is just getting back at me right now. This very moment.
You want to
Oh yeah, I installed,
Went through the whole thing.
deleted everything. We're so close to being able to do what I'm trying to do. So whenever I can do it with one right now, because this one just works.
Well, I think that's it for me. I think I'm gonna crash out early. We did what we came here to do. I'm happy about that. There were some hiccups along the way, but we made it happen. And yes, you can make a large 16-inch tall. Wait, let's measure. I think he's a little shorter now.
Did you put the brackets on?
We did a hybrid bracket. So I used the original ABS brackets for the hips, but I lowered them down. I cut them and they screwed them again.
Oh.
And then because they broke, the ones that I had printed just broke like crazy. This one, this bracket right here, is 3D printed. And it worked well. It prevented the flexing.
Okay, you're probably right, Will. I'm gonna try turning it off and on again, but I'm gonna lose. If I do that, I'm gonna lose this one, which is working.
About 15 and 1/4
So,
inches, or 15 and a half.
Let me
So,
delete this one.
that tall of a robot, you can make walk. With
Oh no!
Woody's
Oh no!
feet to make it happen.
We lost our project.
I have a really solid surface.
Thank goodness for saving. No, we saved it. We're good. So we'll connect to Bioloid, connect to InMove. All right, we're connected to both. Whew. Okay, so
Alright, well,
back to here.
that's it
We
for
don't
me, guys.
have
Thanks for joining in.
any of these.
Yeah,
Okay, let's add this one first.
I like the dab dance.
We're gonna add this one first because it didn't work last time.
I don't know what the takeoff one is. I'm gonna hold them while I execute that one.
Oh, right, we're supposed to turn off on and off
Oh, yeah,
Bluetooth.
there we go.
Forgot to do that too. That's a button here someplace, right?
And balance, I think that was like I believe I can fly.
Oh, weird. Everything was disabled here.
Oh, wow.
There we go, Bluetooth
I don't know
off.
if you can actually do that.
I'll pause for a second.
It's like a cartwheel.
Okay, Bluetooth on.
Alright, let's do one final walk.
Join. Add device. It's weird it says input device.
Maybe we can make that clearer one day. but
What
I think
else
I've had enough
could be around me that's detecting as an input device? Because when I try to turn this on,
Let's make his eyes look yellow and do a sword chop.
like
Get
this
that.
input device, technically I would think is this.
Maybe two dabs back there. Good night, folks. Thanks for joining me. It's been a fun ride. Sign off.
You know what? When this works, it's going to be really awesome. But I just can't get one. I got one Wiimote working fine. This one, it just will not work. Okay, we're going to try another Wiimote. We have lots of them. Okay, here's another one. Add.
We didn't even run out of battery this time. Excellent. Hold the charge, you up.
Oh. They got it. Woohoo! Okay,
What you have to do?
I put it like on top of the laptop.
No way.
All right, good night, Keith. Like I put it like this and it just started, it detected it. Maybe it just was too far away with all the RFs.
Maybe I
Okay, there's one. And let's do the other one. Okay, here we go. Add a device. Wait for this thing to figure its mess out for a second. This input device could be like someone, like a next door neighbor's phone, and they're sitting there and it keeps getting a request or something to it. There, another input device. That must be this one. Got it. Done. Cool. Okay, that was easy peasy. All right. So this one is this one. This one is this one. Okay, see that on the screen? Okay, so I should be able to figure out what arm is for what. Let me see here which arm is for what. Okay, it's this way. It's this way. Okay. All right, Jer. Here's what we're gonna do. We'll do the full room. Okay. So I'm gonna take these Wiimotes, and I'm gonna go. I'm gonna stand over by your desk over there. Okay, so move your chair. Okay, and then what I'm gonna do is I'm gonna control the. I'll put this robot over here more so you can see him. Okay. So I'm gonna control the in move. And then the in move is going to move the Bioloid through the Kinect. So I'm going to remote control the Bioloid from the in move.
This is gonna be good.
Okay?
Yeah.
So here we go. So let me make sure the cameras can see everything here. All right. It won't be able to see me. Can you stand over where I'm going to be? Stand like right. Actually, you know what? I could stand. Right here. Okay, this will work. Okay. There he is.
Picks him up, no problem, eh?
Okay, it's picking him up. Okay. So here we go. You ready, everybody? Well, Will? Okay. Pause off. Oh, you're in the way. You have to go, yeah, you go further that way. No, wrong way. Like closer to, like, go in that far corner over there.
Over here?
No, like over here.
You want me closer?
Out of the picture. There you go. Okay. So what you're seeing is just the in move right now on the screen. That should be good. All right, here we go. Ready?
Yep.
Oh! I gotta turn this off. There we go. Okay. There's arms up.
How do you do it? Do it.
Okay. So here, what we have to do it perfect is hold on, we have to make it so the Wii controllers make his arms go out and like outwards more. So I could do that with this. So this is the x-axis, this is the y-axis. So this one is that, And this one is that. There it is. So this motion here, here, I'll show you on the camera. So this motion here is his arm. We want to put it out. Oh, you know what the problem is going to be? Is I don't think his shoulder actually will move far enough. Hey JR, can you come watch his shoulder and see, make sure it doesn't go up too high for me? Yeah, tell me how high I can go. Tell me when I can't go any further. Is that it? Okay, those are the servos I have to control. So that's D15. And the other one is D19. Okay, 15 and 19 are the two I have to control. So let's see here. So D15, left arm. We'll make it the x-axis, y-axis. Yeah, I'll make it the x-axis. There we go. This is the one. Here, D19. So technically, this one here, there we go, that's what we want. And we want this one to be the same value. So we'll actually remove this one. And then this one is 11. Doesn't do anything at all. Okay, so which one is this that we just change? This one. There we go, that should do it. Now the other arm, we'll have to do the same thing to it, which is this one here. So we want to control this one and this one. I just don't want it to hit anything. Okay. And what's this one? Cool. Okay, let's try this. This should work better. Okay, so we'll go full room. Oops. Okay, let's try this again. Alright, the Kinect's not picking up him anymore. What do we do? Let's try this again. There's a flashing light on the Kinect. What does that mean? Is there a button or something? Oh, it got it. There it goes. Okay. There it goes. Okay. Come on, yeah! Woohoo! It needs some more tweaking, but it's close. This is amazing. Okay, let's try putting it in sitting position. You might pick him up better. Here. You want to try it? Come on. You gotta give it a shot.
Sure.
The one arm works way better than the other.
That's true. Yeah, there we go, we got it. Yeah, reach for the sky. There we go. Right on.
And I put some fine bits. And then take this one, point it down, and twist it. Twist it this way, twist it this way. And go up. Oh, come on, you can do it! There you go.
Doing the YMCA now. That's the C. That's the M.
Oh, this is great.
Let's try it. Let's try the YMCA. Y. Oh, I gotta twist this outward. There we go. There's the Y. And. Oh, stop detecting, unfortunately.
Oh, I got in the way. Oh man, I didn't even realize. I broke it. Okay, try it again. It'll pick it up. Oh. There. There you go.
That's a good C. There's a good A. No, it's an M.
That's an M.
It's an A on the Kinect side. Alright. I've had my fun. Thanks, TJ.
Oh, that's fun. All right. That's it, guys. That is probably like the coolest thing I've ever done. But that's pretty awesome. That's a lot of work just to remote control a robot. You know, like you have, like we went through to think about how it's connected, right? It's like this computer is connected to both robots. Yet the in-move robot's connected to this one through Wi-Fi, which is being controlled by this, right? Just to get an IP address. Then this is connecting to the Kinect, taking the Kinect data, moving the in-move, and then the Kinect data that's being read by the Kinect is moving this. So we remote control the robot on the same computer using two different Wi-Fi networks.
It's like digital to analog, from analog to digital
Oh
again.
man, that's just weird. That's just weird. I gotta draw this out one day, like
I know, I
how
was messing with my head right now.
how confusing it was to set up.
Real world,
Okay.
digital world.
All right, everybody, that is it for me. I'm taking off.
The robot still wants to dance and party.
Yeah, the robot still wants the party. So next week we're not gonna do the IPS today. Not enough work, not enough time. But next week we can play around with the IPS maybe, and I'm sure we'll find out something else to do as well. I'm sure we'll get some ideas.
Maybe,
But
maybe I'll bring the power glove in. We'll control the robots with the power glove instead of the remotes.
yeah, Jeremy's. You have a nice weekend as well, Will. And it snowed here, so we'll try to stay warm. All right, everyone. Take care.
See you guys.
Bye, everybody.